60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas and valuable market trend insights on energy-efficient products and services. IIEE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead.
Welcome. Before we begin our meeting, Please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker, and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
For more than 4 decades, IIEE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIEE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas, and valuable market trend insights on energy-efficient products and services. IIEE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker, and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
For more than 4 decades, IIEE has always been committed to its core values of integrity, innovation, empowerment, and excellence. Founded on September 15, 1975, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, IIEE, is registered with the Securities and Exchange Commission, SEC, as a non-stock, non-profit technical professional organization accredited by the Professional Regulation Commission, or PRC. IIEE started with 500 members and now has grown to a more than 60,000 membership base, with local and foreign chapters in active service across the whole world. Through the years, IIEE continuously commits to upgrade the professional credentials of its members through the Continuing Professional Development or CPD programs, enhance their social standing through the promotion of high ideals of integrity and ethics, facilitate advancement of technology transfer through carefully conceived educational and training programs, and provide opportunity for regular interaction among electrical practitioners. Inspiring future electrical practitioner leaders, IIEE organizes activities such as conferences, conventions, and exhibits showcasing the latest technologies, trends, products and services relevant to the industry, motivating the members to be globally competitive and be able to adequately adapt to the changes, needs and developments that constantly occur in the electrical profession. IIEE activities are planned to be a venue of endless possibilities, new ideas and valuable market trend insights on energy-efficient products and services. IIEE is working together towards one certain goal: to continue to move globally forward so that the Institute will be an esteemed organization with the mission to excel and the vision to lead.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker, and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
Thank you for attending our session this afternoon. We will start in a short while. Good afternoon, everyone. Welcome to the IIEE Standards Committee Technical Sessions. The IIEE Standards Committee Technical team is committed to fully support IIEE in empowering our members in achieving transformational leadership towards sustainable development and realize global recognition and competitiveness. I'm Casey Briones from the Standards Committee, and I will be your host for this session. Our topics this afternoon are aligned on the theme IIEE Standardization Challenges in Electrical Fire Prevention. To open our session this afternoon, we will start with a short prayer followed by the Philippine National Anthem and the IIEE hymn.
Sa kalingat pang unawa, mangyari ang iyong diwa sa langit at sa lupa.
Yang kay tagal lang ng babaya, diyan ko sa ngalipupuduan ko, nadidakim gayang lugay, kimitang yang barog nun. Dalam bawo si balya niya tawag si danginan. Na pagtanaw-tanawin mo, pagsiring-siringin mo yan yung mga dato binukaw. Mga biyakaw bayan na mababay maging kudya matapid mga tang. Sansuid luang nangabat luskod ng binunsali. Yan kay gaong karingat ko yan yung kabayaw ko. Pagpanguyab-kuyaban mo, pagpamayad-payadan mo, ng pinandang pinagalyo, pwedeng dinagansuli. Kay tagal lang, ikaw yung matigam ka namin, walay pagkaibsan, walay pagkawasan. Panganam mo sang wangay, patpid mo sang barantak ng pwedeng mo, wangay ng marigang mo. Ayan, kay tagal lang, naga untong sa amatkan mo, ng kaliko ng bibutang mo, babawin ng dunya, o yan ka namin paggiginawa. Tagal lang ang latso ka namin. Inaagis ang anak mo na tamisa, nagatang hangawanan lingkod sa patiwayan.
Allahumma innaka tara anna hadhihi al-qulub qad ijtama'at ala mahabbatik wattaqat ala hadhihi al-makan imanik wa tawahhadat ala da'awatik fawasik rabitataha ya Allah wa addim uddaha wa amla'aha binurika alladhi la yahbu واسرح صدورنا بفائد الإيمان بك وجميل توكل عليك واهدنا سبل الوحدة والسلام والصلاح ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار يا الله أنت مستجاب لهذا الدعاء وعليك توكلنا وصلى الله على سيدنا محمد وعلى آله وأصحابه أجمعين آمين الله أكبر الله أكبر الله أكبر.
Mahabagin naming Ama, Ikaw ang aming sandigan at lakas. Ikaw ang kaligtasan ng aming katawan at kaluluwa. Naway takpan mo po kami ng iyong mapagkalingang kamay upang mayadyak kami sa mga pahirap at karamdaman at sa lahat ng masama dala ng makabagong mundo. Hinihingi po namin na sana'y ilayo po ninyo ang mahal naming lungsod ng Tagum sa mga mapinsalang kalamidad at sakuna. Mahal naming Panginoon, Ikaw ang aming proteksyon at gabay. Sa oras ng pasakit at pangamba, bigyan niyo po kami ng sapat na lakas upang aming mapagtagumpayan ang lahat ng pagsubok sa aming buhay sa pangalan ni Jesus. Amen.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. God, our loving Father, Creator of heaven and earth, we thank you for your generosity and kindness, and ask that you hear us in times of needs. Make us worthy of your blessing, and keep us from further want. Help us restore our abundance here on earth, so that we may turn more attention to your divine kingdom. Help us become a blessing to our family and others, to glorify and honor your name. We ask this to our Lord Jesus Christ, your Son, who lives and reigns with you in the unity of the Holy Spirit, one God, forever and ever. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Iadya niyo kami sa pagmamataas upang maiwaksi ang lupit at dahas. At samahang lumikha ng pamayanang payapa sa kalikasan kabuhayan, kakanyahat paniniwala.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, telas ng sinanalan, alam ng puso, sa likid mo'y buhay. Upang hinirang, tuyak ka ng magiting, sa manlulupin, di ka pasisikin, sa nalagang tutok sa simoy at sa langit ng pagaw, ay hinatang tulad, awit sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na nag-iingin, ang bituin at araw niya kailan ang may di magtitingin. Luman ang araw ng walhaging pagsinta, buhay langit sa piling mo. Ang hindi kaya ng pagkay mga akin, ang mamatay ng dahil sa'yo.
We are one in IIEE mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contribution to our nation. To any challenge involving what's phones and bolts, BEREE and RME, connecting industries by the electric circuits. Bind us together, IIEE. Bind us forever, IIEE. With power cords cannot be broken. Bind us together, IIEE. Bind us together, IIEE. Bind us forever, IIEE. Synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission quick for reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Bind us truth. No one else can substitute. There's only one
Welcome once again to our session this afternoon. To open our webinar, may we welcome Engineer Esperanza A. Collado, the National Vice President for External Affairs.
Ladies and gentlemen, distinguished guests, and members of the Standards Committee, headed by Sir Conrad Binondo, good morning to you all. Welcome to this insightful webinar on standardization challenges in electrical fire prevention. As we gather in the celebration of the Fire Prevention Month, we embark on a crucial exploration of the challenges and solutions in ensuring electrical safety through robust standards. Let us delve into the intricacies of this vital subject, fostering knowledge and collaboration for a safer, fire-resilient future. Throughout the Fire Prevention Month, it is essential to underscore the significance of standardized practices in mitigating electrical fire risks. Our esteemed speakers today will illuminate the complex landscape of electrical systems, addressing challenges and proposing innovative solutions. As we collectively navigate this critical domain, may the insights gained pave the way for enhanced safety measures, fostering a proactive approach to electrical fire prevention in our communities and beyond. Thank you for joining us on this imperative journey. Again, good morning to each and every one of you.
Thank you, Ms. Shi, for that very inspiring message for this afternoon. Again, welcome to our session this afternoon. This will be a very productive session in alignment to the thrust of the Fire Prevention Month. Okay. To start our session today, our first speaker is Engineer Conrado C. Binondo, our professional electrical engineer under the IIEE Standards Committee, and the first Filipino to receive the 2022 IEC 1906 award from the IEC Geneva, Switzerland, in recognition of his long-term contribution with deep expertise in electrical installation and protection against electrical shock, and especially IEC TC64 plenary meeting. He has gained wide experience in the design, manufacturing, testing, and commissioning of medium voltage and low voltage switchgears in Riyadh factory for panel board under license of BBC and Calor EMAG, and Arabian Manufacturing and Electrical Services, companies under license of Schneider Electric and Siemens. After his stint abroad, he put up Elecdesk Training and Technical Services, specializing in generator synchronizing control systems. He is the registered expert of IEC TC64WG43, the chairman of BPS TC77, a member of TC69, and of IEC National Committee of the Philippine Standard Management Board, and member of BPS TC10, and also a member of UPEP and Board of Trustee of NPAP, and chairman of the IIEE Standards Committee. He is here to share the overview of PNS IEC 60364, Part 4-42, the protection against thermal effects. Once again, let's welcome Sir Conrad. Good afternoon, sir.
Hi, good afternoon, everyone. This is a good day. Good start for this month that we're going to celebrate the Fire Prevention Month. And the Standards Committee is bringing you here 3 experts, local and foreign experts, to discuss about the challenges that we are encountering, especially when it comes to electrical fire. So I will begin this webinar with the presentation of the IEC standards on thermal effects, part 60364, part 4-42. So just relax and let's enjoy this webinar, and I will take you to the journey of how IEC addresses the prevention of electrical fires. Okay, so let me share my screen. Let me remove this. Okay then. So here in front of you, this is the title of our presentation this afternoon. Actually, probably we will not reach an hour because I'm just talking about the overview. I will introduce to you the requirements or what's all about this part of the standard. So this is PNS. PNS stands for Philippine National Standard, and it's IEC 60364 part 4-42. Now in every discussions that we are going to introduce to everyone, normally these are IEC standards, but if it's being adopted as a Philippine National Standards, so we have to add before the IEC the acronym of the PNS, because we want also to promote what standards have been adopted. Either this is IEC, it's ISO, or UL, or ANSI standards. Okay, and of course, it's through the Bureau of the Philippine Standards, the government agency, who is the main what we call this contact agency in the Philippines for all these international standards. So it's in the observation of the Fire Prevention Month. We are presenting, this is the first time that we have done this in the Standards Committee, and we will have a series of seminars on the coming few months, because this is a part of our program to introduce commonly used standards, or what we call this. This is the updated standards also here in the Philippines. So we will have some idea on how important, on how we can use in our practice these standards. Okay. So the IEC and PNS reference for this topic, we have what we call the low voltage installation rules in IEC. It's the number IEC 60364. It's a series of standards, and the topic that we're going to discuss this afternoon is a part of it. So before you could see on the left, it's only IEC 60364. Then after after its adoption, it became now a Philippine National Standard. So it's now PNS IEC 60364. That's one. And this standard actually was adopted in the year 2020. Okay, then it talks about the fundamental principles and assessment of general characteristics and definitions of the standards. So this one is for low voltage electrical installations. If you could compare this to our Philippine Electrical Code, so if you look onto the most of the application or the guidance that we see, the requirements are, the majority are all on the low voltage installation. So we will have also some brief comparison on how the PEC one is related to this standard. In using the adopted standards, so I just want to inform everyone that the full series of standards of the PNS of the 60364 standards has been adopted in last 2022. So now the 60364 is available in BPS. All the parts of this standard, you can have an access or purchase this in BPS, the Bureau of Philippine Standards. Okay, now if you need reference like this, because if you want to bring this from the IEC web store, then it's costly, the amount of all these standards. But because it's been adopted as a Philippine national standard, then it's readily available with the BPS. Okay. Of course, it's very important that whenever we use this standard in our work, or use it as a reference, there's a country note that is required by the ISO rules. That the use of this standard shall be in accordance. Let me just put my laser. Okay, shall be in conjunction with the latest edition of the Philippine Electrical Code. So always we have to look onto our code, because our code is the legal document or code as a reference in the electrical installation in the Philippines. Okay, while both address the requirements of protection for safety, but we have to really, as a profession, as an electrical engineer, to be cautious, on using the IEC reference, because the IEC as a standard is just what we call this, is not usable in actual applications. Then what we are going to do, we have to develop guidelines, application guides out from all these standards, because these standards requirements are all mandatory. Okay, like our code, it's mandatory. Then also this standards is mandatory. When it's being adopted as a code locally, then it will become mandatory. Whenever you have standards, you can adopt it in toto, you can adopt it a part of the standard, and you can use it. But of course, in every part of the standards are going to include in the code, then there should be what we call a permission from the author or the organization where the standards came from. So the PRC likewise adopts the latest edition of the Philippine Electrical Code, Part 1, as the part of the rules and regulations governing the practice of electrical engineering, and as a referral code in accordance with the National Building Code. So take note of this disclaimer here. Should there be any difference in interpretation on the provision and requirements of this standard and the Philippine Electrical Code Part 1, the provisions of the Philippine Electrical Code shall be maintained. Okay, so this is a very important note to look at, to consider. Well, this is same. So I'm bringing you to this part of the standard, so we will know exactly where this part 442 came from, because to understand this part that we're talking now, the thermal effects, protection against thermal effects, we have to know the whole structure of the standards, which is the IEC 60364. Okay, and this is a creation of the standard series. Now, there are some 35 documents. Okay, so imagine there are 35 documents. And the topic we're going to discuss now is only a part. It's only a part of these 35 documents. Then into which there will be 21 sections corresponding to spatial locations. So similarly, we have also spatial locations installation in the Philippine Electrical Code. Okay. And all these documents are independent and complementary. So they complement each other. And there are 6 main parts of the standard. So number 1 is the part 1. We call it part 1. This is the fundamental principles. Then part 4, this is the protection for safety. Maybe you will question, where is 2 and 3? Actually, 2 and 3 has been deleted and was integrated to the other parts of the standards. You know, the TC64, who is in charge for this standard, Technical Committee 64. They have a lot of teams. They have what called maintenance team, project team, and working groups, working on all these standards. So it's a decision of the committee to remove and transfer up other parts, so to make it more like what we call friendly user standards. Then we have part 5. We have the selection and erection of the electrical equipment. We have part 6. This is verification and test. I will explain further this one in the next slides. And then we have part 7. It's all about spatial locations. Okay. Then part 8, we have the functional aspects of this standard. And part 4, 5, 7, and 8 are made of several parts or sections. Okay, part 4, for example, protection for safety. You will see now there are 4 protection for safety. Now, this is a diagram of how it looks, the overview and the structure of the standards. The part 1, it's about fundamental principles, requirements, of the standards. So what are these? Of course, you have the scope. You will define here the scope of the standards. Then here it defines also protection for safety, that the installation must be safe. Okay, so there is a general line, guidelines there that you have to provide safety, provide safety in your installation. Then another one is, of course, very important is compliance to product standard, because product installation and product standards, they walk, they go hand in hand. You cannot separate the two. Okay, because product standards are all, for example, tested in laboratories, manufactured and tested. Okay, while they are being tested to validate their performance in the laboratories, then it passes certain tests, qualifications, certifications. But the moment it goes out of the manufacturer's premises, then the user now has to install these devices, for example, into an enclosure, into any other locations. So because of the external influences outside, surrounding these products, then it changes everything. Then there are rules, also guidelines, and how to install it properly, how to probably derate or uprate your equipment or your devices in the installation. Okay, so there are 2 we have to look at always in electrical installation, the product standards, products that we are going to use, and the installation requirements that we are going to follow. Very important as part of the safety of the installation is concerned is here is the earthing systems. So these earthing systems, it defines actually the types of earthing that is commonly used by IEC. So here, if you could see, there are 3, but if you summarize this, there are only 2. Okay, we have the TN and IT, because TT is a grounded system, TN is a grounded system, and I is isolated or ungrounded. Similarly, this is our Philippine Electrical Code. We have also 2 grounding system grounding. This is the grounded system and the ungrounded system. Okay, so they are similar. Okay, but again, we have separate discussions on this earthing system. Then, of course, separate circuits are being also mentioned in the fundamental principles. Of course, it includes the assessment, general characteristic, and definitions of terms. It's very important to know all the definitions to understand. When you read, you know the definitions of all the terms mentioned in the standards. Then it gives the rules for the design, erection, and verification of electrical installations. So we can see similarities with our Philippine Electrical Code. Okay. So what are these? So what are the rules intended for? Is to provide for the safety of persons. Okay. So code natin is more on hazard, protection against electrical hazard. So for this, it's the same. Safety for persons, livestock, property against dangers and damage that may arise in the reasonable use of electrical installations, and provide for proper functioning of those installation. Okay, one of the hazards here will be the fire, yung pinag-uusapan natin ngayon, pag-usapan nating topic. Then, of course, this covers, very important to know that this standard covers circuit supplied at nominal voltage up to and including 1,000 volts AC or 1,500 volts DC. Okay, this is very common now. For example, the DC side, we have a lot of installation when it comes to the PV, the BES, BES, and wind power. So we will see voltages up to 1,500 volts DC. Okay, so it covers also this type of installations and the voltage. Above 1,000 volts, above all these voltages, we have another standards in IEC. It's another standards which covers above 1 kV. So it's not anymore low voltage, but it's already high voltage. So there are only two. There is low voltage and high voltage. So beyond 1,000 volts AC and 1,500 volts DC, these are considered as high voltage. Okay. Now, these are the hazards in electrical installation. Shock currents. Okay. Of course, you have to protect persons against electrical shock. And excessive temperatures. This is our topic. Likely to cause burns, fires, and other injurious effects. And what are ignition of potentially explosive atmosphere? We have under voltages, over voltages, and electromagnetic influences likely to cause or result in injury or damage. We have the power supply interruptions, or interruptions of safety services. There is arcing, likely to cause blinding effects, excessive pressure, and or toxic gases. The mechanical movement of electrically activated equipment. And these are the hazards mentioned in this standards. Okay, the application. Where do we apply this standard? Number one is for residential premises. That is one of the main priority purpose of the standard is always the safety of persons in residential premises. And number two, in public, of course, premises, we consider this in this standard. And number C is industrial premises, agricultural and horticultural premises, prefabricated buildings. We have caravans, caravan sites, and similar sites. We have marinas, of course, and this one, medical locations, by the hospitals, everything there. Healthcare facilities. These are all considered in this standard. Construction sites, exhibitions, fairs, and other installations for temporary purposes, and external lighting and similar installations. So mobile or transportable units. We have photovoltaic systems, the PV, and we have the low voltage generating sets. Okay, these are the applications of these standards. Now, let's go to the part 4. So the fundamental principles is explaining the scope, of course, of the standards. Then another one is the part 4. This is the protection for safety, which is being considered, in chapter 131 of the fundamental principles. Number 1 is the chapter 41. You could see this protection against electric shock. Then chapter 42. Okay, protection against thermal effects. Then chapter 43, protection against overcurrent. Chapter 44 is protection against overvoltage and electromagnetic disturbance. So this is the requirements of the installation when it comes to protection. To have a safe installation, you have to follow the requirements of the standards. Okay, so this is our topic, part 442. Then, when you already know the requirements of the installation when it comes to safety, then you have to address also now the selection of the devices. So what we call here is just the selection and erection sorry, of the electrical equipment. Okay. A while ago, we were talking about product standards. So this is where now we see where the relationship, no, on using the products in terms of meeting the requirements, no, and the protection for safety. Okay, so there is a common rules here. The external influences, this is part 51. We have part 52. This is wiring selections. This one is very good reference because this will show the installation methods of the wires. No? Okay, and also what we call the current carrying capacity of all the wires conductors that's being used in IEC. Okay, you consider yung tawag natin yung mga ampacity, ganun. But in IEC, they call it current carrying capacities. The installation methods, how they will install this one in cable tray, in conduits, okay, in the wall. So many ways. Then in chapter 53, you will discuss here the protective device selection. Of course, when you want to address the issue on thermal effects, then you have a device called, for example, AFDD, no? Arc fault detection device. SPD is more on voltage and surge protection. And of course, we have the RCD, more on protection against thermal effects, against electric shock. And we have circuit breaker, that is protection against overcurrent. So here it will specify types of circuit breakers that you're going to use in your installation. Then, of course, earthing arrangement. This is similar to our PEC 1 Article 2.50. This is the earthing and bonding, okay, requirements. And this in IEC, we have the earthing arrangement. You can see here also. This is in relation to the chapter 312 in the fundamental principles. The earthing system is mentioned here. But here, this will be the earthing arrangement in the installation, in the premises. Okay, how do you bond your exposed conductive parts? Okay, how you ground your exposed conductive parts? Okay, so it's being specified in this chapter. Then of course we have other equipment. Okay, like the low voltage generators. It's here, one of it, and the safety services. Okay, we have fire pumps, fire. How would you install? Okay, your fire safety equipment. It's all in the safety services. Okay, so that is the explanation of the device selections. Then after the installation, okay, and during the installation, while you have already complied with the requirements for safety and you have already selected all the devices for your installation, your equipment, then you install it at site. So what you're going to do, you conduct verification, okay? This is what we call inspection during installation. So online, inline inspection. Then, of course, during this, when the project is commissioned, then we have to conduct what we call periodic verification to validate the satisfactory conditions of the installation. Okay, so we cannot just leave the installation and keep it there working because it's required, no? It's mandatory requirements to conduct preventive maintenance. This is now what we call preventive maintenance, the way how we understand it in our here locally. But in IEC, we call it the periodic verification to validate if still your installation is according to what's being designed for and according to the usage of all the device and equipment that's being installed in the installation. So you have to do verification. Okay. Now, another one, which is a common now trend, in our industry and all the installation. We are talking now about energy efficiency, okay, and conservation. We have the Republic Act 11285, wherein we discuss about having an efficient installation, okay, and how to conserve energy. So part 8.1 actually is all about the installation meeting the requirements of IEC, how to have an efficient installation, okay. Then we have part 8.5, prosumer installation, wherein you your energy, and you also export the energy, excess energy. So you produce and consume. That is prosumer. It's an IEC terminology that came out from this standard. Then we have the operation of the prosumer installations, how to operate this. Okay. The part 7, this is now the spatial locations. You could see probably a similar requirements in our code. In Philippine Electrical Code, for example, we address the installation in a bathroom, 701. Also, swimming pools and other basins. Okay, you address this one because there are specific requirements in the spatial locations which may alter the requirements in part 4. No? Okay, or part 5. But this one, you have a spatial requirements, so you have to address this to have a safe installation. Then you have locations containing sauna heaters. We have construction and demolition sites. Okay, you have this is also spatial locations. We have the agricultural and horticultural premises. In 706, restrictive conductive locations, caravan parks and caravan in 708, 709, marinas and pleasure craft. 710, this is very important, medical locations. So you have to, if you want to see how easy is the installation requirements for medical locations, it's in this standard 710. Exhibition shows and stands. Okay, we have again another important document, very common in our installation nowadays, is 712, the PV, photovoltaic system. You see, PV is another. When you talk about products, then you have the product standards of the PV, which is in TC, what we call the 82 of the IEC. For the installation, it's more on TC 64. So it covers the installation of a PV. Then we have the furnitures, section, external lighting, extra low voltage lighting installations, mobile or transportable units, communal facilities, workplace, and section 7 is electrical installations in caravans and motor caravans. Then the supply for electrical vehicle. So this is another subject which we have to look onto. Actually, it's only supply. It's not. It's up to the outlet only. How you supply the for example the EV charging station. So the EV is not a part of the 60 of this standard section 722. It's up to the supply point only, like the socket, outlet. So we are considering this in the standard. Then operating or maintenance gangways, sections, and the temporary structures, these are being considered. Floor and ceiling heating systems. Okay, then these parts are not standalone documents and shall be used with parts 1 to 6 and 8. Okay, so you have to always remember that these are not standalone document. So, ladies and gentlemen, this is the overview of the structure of IEC 60364. I explained this standard so that we will understand really where this the discussions, now the topic, came from. Okay, it's very important to know this one. So at least we have an overview diagram like this, and whenever we need references on our installations and our low voltage installations, then go back to this structure. Then you can really request or purchase, for example, the standards in BPS. So I repeat, this is already all of this. We have it was adopted already as a Philippine national standards. So it's readily available with the Bureau of the Philippine Standards. Okay. The standards, of course, again, this is what we have adopted specifically because we're talking protection for safety. So this was initially adopted in 2020, all these standards, because we focus the Bureau of Philippine Standards Technical Committee 77, where also I chair this committee. Then we recommended this one for to be adopted as PNS. Now it's circulated now as a PNS IEC standards. Okay. So where are we now? 60364. This is now part 4. So we talk about the part 4s. So you could see part 441, protection against electric shock. Part 442, protection against thermal effects. Part 440, protection against overcurrent. Part 44, protection against overvoltage. So let's see the relationship, with our Philippine Electrical Code. And then the next slide after this, we will see now what are these. The type of protection, as I mentioned here, protection against electric shock is, of course, being addressed. Basic protection, fault protection, enhanced and additional protection. So there's a topic, separate topic for this. And now protection against thermal effects, of course, it's protection against fires and burns. Ito yung topic natin ngayon. Then protection against overcurrent is more on overloads and short circuits. Okay. Then protection against overvoltage, okay, it's more in industrial and high frequency voltages, yung mga industrial high voltage natin. Effects of overvoltages like lightning, okay, the effects of those. Then what are the concerns here? The applications of this protection for safety. So ang tinitignan dito is you're going to protect persons and livestock. Okay? Protection and livestock. Then protection of properties. Okay, ano yung properties? This is our electrical equipment and buildings, yung residential premises natin. Okay? So if you see this table, this matrix, para hindi tayo malito, so we protect persons against electric shock dito and against thermal effects, burns, fires and burns. So ito yung tao, tayo. We have to protect it here. So hindi siya sa overcurrent or overvoltage. Okay? So properties, of course, electric shock, di naman yun, so it's life. Then it will be thermal effects, as mentioned here, fires and burns. So ito yung niya. Then overcurrent, if you have overcurrent, what you're going to protect, your property, hindi yung tao. Okay, remember this. And if there are over voltages in your system, in your installation, you protect the properties. Okay, so this is clearly defined here. The application of the protection on person and properties. Okay, so let's see the relationship. If you go back to your, if you read the PEC 1, Article 1.0, PEC 2017, here in relation to other international standards, from here you could see that the requirement of the code considers the fundamental principles of protection for safety contained in Section 131 of IEC Standard 60364 Part 1. So ito yung kanina, yung sa part 1, yung generalities, yung fundamental principles, And here, if you check the fine print note in section 1, it contains fundamental principles of protection for safety, that protection against electric shock. Ito na yun. So side by side, let's see where it's coming from. This one, from the IEC part, okay? So 131.2, protection against electric shock. Protection against thermal effects, protection against thermal effect here. This is our topic. 131.3, protection against overcurrent, protection against overcurrent. Okay, protection against fault currents, protection against fault currents, and protection against over voltages. Okay, similarly, it's the same as protection against voltage disturbance. And nadagdag sa IEC is electromagnetic, influences. Okay, so ito yung mga nadagdag dyan. Over voltage, under voltage, electromagnetic disturbances. So you look at this, hindi siya, baka sabihin natin mamaya, magkasalungat sila. When it comes to safety, protection for safety, both address the requirements to protect life and property. Okay. Now, this is the cover page ng standards It's actually in 2010. Okay, ito edition. Then the last one, the current one is 2014 yung edition niya. So ito ngayon yung mabibili nyo sa BPS kung bibili kayo, no? PNS, IEC. But now in the technical committee, those are working in IEC, there is a final draft, we call it FDs, final draft international standard stage, no? Because we have to improve the standards based on the relevant of the standards now. Then it should be published by the end of 2024. Okay, this FDs, if it will be approved by the national committees, then it will become edition na 2000 and 2024 na yan. Itong bago. Okay. Now let's go now to the main topic. So, mahaba yung introduction, para at least we understand really where it's coming from. So I'm just talking about the overview, no? Mamaya, after this topic, the other speakers, they will talk more in detail yung mga applications, especially yung si Jade Francois Ray. He is a specialist, no, in this type of installation. Tignan natin lahat. We will learn from this. And of course, si Vic will be on PV, more on the installation of the PV. So a very good topic also. Okay, so this one applies to electrical installations concerning measures. So we have to have some measures for the protection of person, livestock, and property against what? Thermal effects, combustion and degradation of materials, and risk of burns caused by electrical equipment. Protection against flames in case of fire hazard being propagated from electrical installations to other fire compartments segregated by barriers are in the vicinity. And 3, the impairment of the safe functioning of electrical equipment, including safety services. So ito yung pinaka yung parang abstract niya of this presentation. Ano talaga yung purpose nito. And the scope here, which are the main clauses of the standard. Of course, you have what we call protection against fire. Ito yun, no? Yung pag may sunog against fire, paano ka mapoproteksyonan? How would you protect your installation against fire? So, installation of equipment. Okay? Requirements for BD2, BD3, and BD4. So, probably magtataka kayo, ano ba itong mga requirement ng BD2, BD3? This is a part of another standard wherein we define, actually, in the common rules, BD stands for the conditions of evacuation in an emergency. So ano yung condition ng evacuation doon sa facilities mo pag nagkaroon ka ng emergency situation, may sunog, anong gagawin mo, di ba? So here it addresses BD2, BD3 and BD4. So ano yung BD2? BD2 is we talk about the conditions of evacuation. Ito yung low density occupation, low density. So, yung yung difficulties of condition and on evacuation, medyo meron siyang kunting difficulty, no? Ano example nito? This is the high-rise buildings, no? So, maaring yung high-rise building, yung occupation is low density, pero since na high-rise siya, medyo considered na yung evacuation mo ay medyo mahirap ng kunti, di ba? Mahirap yung bumaba, di ba? So, we call it the BD2 classification. Merong BD1, but it's not considered here. Kasi ito naman, yung mga BD1 is a low density. Madaling mag-exit, no? For example, yung buildings na normal, yung low height, no? Used for habitation, like our residence, no? Ito yung mga BD1. Then BD3 are those what actually high density occupation, then easy conditions of evacuation din. Then locations are open to public, no? Public areas like theaters, cinemas, department stores. These are considered as BD3. Okay, so BD4, yung mga high density na occupation, no? Ano yung mga high density na occupations? So ang difficult conditions nito of evacuation medyo mataas yung kanya, no? Yung rate niya, yung difficulties. High-rise yung building, probably, and open to the public. Maraming public, may private, may mga. So, ang example nito are the hotels, hospitals, no? And so on, no? So this part of the classification on the conditions of evacuation as being addressed by this standard is we can see this in the table, yung isang kanina, yung part 551, no, of the standards. Merong table dun, so makikita natin lahat yung classifications, no, when it comes to the buildings, evacuation, and so on and so forth. Okay, then there's another one here, the nature of the stored materials. Okay, so meron tayong the nature of stored materials. We call it BE. BE2, yung kino-consider dito, BE2, this is the nature of the process. Ano yung ginagawa dun sa installation? The nature, yung proseso, mga process mo, no? Or ano yung ini-store mong mga materials. So there are risks, ano, dun sa installation na yon. So BE2 is actually fire risk. Yung nature mo. So ang fire risk nito, kung mag-manufacture ka, or like the processing of flammable materials, including the presence of dust. So ito yung mga installation na katulad ng mga burns, yung woodworking shops, no? Paper factories. So we consider those as BE2, no? Type of location, no? Mga buildings. Then BE3, hindi na sa BE2 lang ito kasi fire. Then we have also CA2, yung combustible buildings. We have to protect this one. Pag CA2 yung mga buildings natin, this is the construction of the building. For example, kung sinabi ng CA2, this is combustible. Ito yung mga building constructed mainly out of combustible materials. For example, wooden buildings. Yung sa atin dito, yung law, anong tawag nila doon? Materials, no? Light materials, kaya madaling nasusunog. Sa mga informal settlers natin, marami dyan. Madaling masunog yung mga bahay nila, no? So they are considered as CA2, no? Okay, to protect this type of facilities or locations. So fire disseminating structures, yung CB2, this pertains to the building design. So CB2 is the propagation of fire. Paano magpa-propagate yung fire dito? Okay, which for example, yung building mo, yung pag dinedesign mo, you take into consideration yung dimensions and shape, ano, para maiwasan mo yung tinatawag nila na the spread of fire, no? So meron ding mga ganon, like what, for example, yung tinatawag nilang chimney effect, ano? Okay, so that is CB2. And then here, ano pa yung ibang protection, no? Protectionan mo. Then recommended to protect against the effects of arc faults. Ito na yung very common, which will be discussed in the next by our experts, you know? In the final circuits, in bedroom or locations with risk of fire, ano yun, arc fault detection device complying with this standard IEC 62606. Similarly, this is the arc fault interrupting, yung AFCI natin, current interrupter, no? Arc fault current interrupter, AFCI, which is of course sa next edition siguro ng PEC natin, baka babalik ulit yun, yung AFCI. Then another one is the main closest protection against burn. This is the maximum temperature of accessible parts. There are limitations when you hold some parts of the installation, di ba? May certain temperature yan. Okay, not to cause burns doon sa kamay mo. Siyempre, pag napakainit at nakakapaso, hindi mo mahawakan yan. So, this standard also consider that the protection, no, against this type of excessive temperature. Protection against overheating, there is forced air heating systems. Maaaring meron kang heating system doon sa installation, pero normal ito sa Europe, sa ibang bansa na malamig. So, meron ganun. Sumobra yung heating mo. Di ba? Masunog ka. Di ba? Or the appliances producing hot water. Di ba? Merong regulation yung sa water, nililigo ka, merong hot water, or sa steam, tumaas ng tumaas. So, all of these things, it's being considered, na maproteksyonan yung mga tao dito sa effect ng overheating. Then we have here the protection against fires and arc caused by electrical equipment. Of course, we will use AFDD. Very important, another part of these standards, the precautions where particular risk of fire exists, wherein, for example, we want to use residual current device to protect our installation against fire. So ito, dalawa yung RCD, meron tayong protection against electric shock. Ito yung 30 milliamperes as defined in the standard. Of course, GFCI is 46 milliamperes, mga ganun. But here, in this one is the 300 milliamperes. If you use this one, is primarily used in protection against the risk of fire. Okay, so pen is forbidden. This is yung pen kasi sa standard is the common, neutral, and protective earth. They are common. So ang possibility nito, forbidden ito because of the very high current that passes. Imagine, neutral current mo, dadaan doon. Fault current mo, dadaan on the same conductor. So it's very high. Yung risk ng current mo during fault conditions, napakataas. So it's being forbidden. Then, of course, protection against burn. Here, example, minsan nagtataka tayo, where did it originate? Bakit nasunog yung bahay ko? Ganyan, okay naman siguro yung mga outlet ko, compliance naman. Then probably we can consider something na hindi natin nakikita on the behind the walls. For example, mga cables, di ba? Or on the ceiling, may mga cables dyan. Particularly kung ang kwan natin kanina, yung type na wooden, light materials, yung mga dinaanan ng mga cables. Okay? So again, the causes of fire and electrical cause of fire, they use improper earthing system. So very important, kung meron tayong installation, let's look on the type of earthing we are using. Ito, grounded system ito, So we have to be very careful na kapag nakita mo, grounded system na ganyan, TNC, nagsama yung neutral, tsaka yung protective earth mo, medyo ayusin na yun, Kasi yung risk of fire is very high dito. Then overting of cables due to overload, of course, sometimes ito palagi yung sinasabi natin na overloaded kaya nasunog, overloaded, di ba? Ang daming ganitong terminology. Overloaded yung equipment, overloaded yung socket, mga ganon. Then, yung deterioration of cable insulation, pag na-deteriorate yung kon mo, because probably temperature, matagal na yung cable mo, o maaaring ito medyo kinain ng mga rodent, di ba? Ngat nila, so na-expose. So maaaring magkaroon tayo ng issue dyan, part of this. And of course, bad connections. Ito yung isa sa mga main issue, sa ating mga installations, yung connections natin sa mga terminals. Okay, we tighten it, tapos wala na, iniwan ng ganon. Wala nang maintenance, hindi na nire-tighten. Kaya normally, meron tayong annual preventive maintenance to conduct tightening of connections, lalo sa mga terminals, like using torque wrench. So already, it will be a part of our code, yung bago. There will be, nakalagay na dun yung torque. So watch out for this one, yung mga connections. It's required now to have a torque on all the connections. Hindi lang part of the maintenance, pero it's a requirement now of our installation code. Okay, napakahalaga yan. Electric spark at connecting point. Ito, mga loose din ito. Connections sometimes or things na merong leakage tulad na sa picture na ito. Diba? Meron kang leakage. It's dangerous because imagine kanina pinag-uusapan natin 300 milliamperes. Then here, 270 milliamperes is enough to ignite a fire. Okay? So in insulation failure between this line conductor and the earth, ito yung sa body niya, for example, in dusty and in humid environments, lalo na nagsama, can lead to an arc fault of low intensity, okay, according to the line conductor withstand, kung ano yung mawithstand na conductor, but still, it's high enough to start a fire. So some tests sa laboratory, mga tinesting have shown that in event of fault current as low as 300 milliamperes can induce, okay, nag-induce siya na real risk of fire. So ito yung figures na nakikita natin dito. Then a polluted and a damp insulation surface can enable small electrical discharges causing carbon deposits that increases conductivity. So napabayaan, nag-carbon-carbon na siya. So alam mo naman na carbon, conductive yan. So yun, umpisa na ng sunog. Okay, and another one permanent leakage current through the insulation. Ito, illustrations. So this take note, these are the electrical causes of fire kung saan no? Ano ba yung sinasabi nila? Yung bad electrical pag sinisisi na may sunog. Palaging electrical ang tinitignan nila. But if you look onto this one, talagang kung hindi napabayaan natin lahat ito, it will really cause fire. Okay? Then the RCD, further if you want to see this one, yung the use of RCD in distribution feeders, okay, recommended sensitivity less than 500 milliamperes. So generally 300 yan. So sa mga product standards, you can always see 300 milliamperes. Then purpose nun, you want to protect your installation against fire, okay? The risk of fire. So RCD must break the neutral. No? So very important sa requirements sa erection parts ng installation mo. You have to break the neutral. Hindi pwedeng yung neutral mo nandun pa rin. So as you see in this one, okay, continuous pa rin yung flow ng current sa neutral kahit na nag-open na yung phase mo. Ayan, may dumadaan pa sa mga ibang equipment, di ba? So kung mayroon kang fault na ganyan, continuous pa rin yung flow ng fault current mo dun sa installation mo. So ang requirements, laki-laki nito, you must break the neutral. So insulation fault is not always eliminated by a device with only one phase break. Use phases plus neutral breaking device with simultaneous opening of all the poles. Okay. Then now, very important device in the installation, yung final circuits. We're talking about the final circuits. The final circuits is between probably yung outlet mo, the outlet, and of course yung panel mo, di ba? Wherein you install your AFDD. So ito yung tinatawag na final circuits. Doon ka na hanggang sa kwan mo, hanggang doon sa outlet mo. So for final circuits, AFDD, arc fault detection device, is recommended for specific locations. So the use of AFDD is to protect against arc fault in final circuits is recommended. No? So the premises sleeping accommodations, mandatory na yan. So I think in Europe, probably we will know this more from our third speaker, no? In premises sleeping. In locations with fire risk due to the nature of processed or stored materials, that is burned, woodworking shops, stores, or combustible materials. In locations with combustible or constructional materials. In fire-propagating structures. No? In locations which endanger replaceable goods. Okay, yung replaceable goods, ito yung mga museums natin. Tulad ng yung post office natin nasunog, di ba? Natin alam kung anong dahilan nun, pero ito yung sinasabi na irreplaceable na kapag mayroong mga artifacts, no? Yung mga high-valued, wala na yon pag nasunog. Okay? So in AC circuits, the use of arc fault detection device, AFDD for short, in compliance with the IEEE, ito yung standard ng AFDD, will satisfy the above-mentioned recommendation. The AFDD shall be installed, ito kanina sinasabi ko, at the origin of the final circuits to be protected. Okay? Yun ang kanyan, the way you install sa panel mo, yung lighting and power panel board mo siguro, nandun siya yung AFDD. So now, pinag-uusapan natin kanina is the previous version of the standards. This is up to 2014. Now, kanina nabanggit ko na meron final draft international standards which will be published probably, sabi ni Chairman, ng TC64 2024. And what are these? So ito yung mga additional, will not go more in details kasi meron pang ibang speakers tayo. So it considers now status group of safety publication na siya. Okay, from the previous edition, new subclause, may mga bago regarding measures for preventing fire originating from the use of an electrical stove, cooker, and hob. No? So na-consider na yan. So new clauses 426 for additional protective measure against thermal effects for locations where consequences of fire are severe, including former subclause 421.7. Then merong bago na naman na clause for protection against fires due to fault currents, yung matataas na fault currents. The new clauses for protection against assembly internal arc faults. Ito yung meron tayong mga enclosures na merong arc fault di ba, mitigation. So yung internal arc fault na yon nako-consider na rito. Then improvement of escape routes. Paano tayo mag-exit doon sa mga natin, installation facilities natin. Okay, improvement for final circuits in BE2 locations, then improvement for locations with irreplaceable goods or with business critical facilities. So may mga improvement na ginawa dito sa bagong version ng standard. So ito, yung measures na yan is the same na gagawin dyan. Then we have of course the protection against fire by electrical equipment, so it will be similar. Okay, yung improvement na yan, so nandito sinabi nila ulit dito sa standards na ito. Okay, then where external influences present particular risk during a fire, so ito yung mga categories: CA2 combustible for construction materials, CB2 propagation of fire for buildings, so yung mga boxes and enclosures shall be selected according to this standard. Location with irreplaceable goods or with business critical facilities, electrical circuits shall resist a fire for at least 1 hour. So meron siyang limitation, yung circuit mo, mag-resist niya in 1 hour. So wiring shall be a non-flame propagating. Ito yung flame retardant or tulad ng ginagamit natin mga cables, yung kulay orange, yun yung mga wiring system na ginagamit natin. Okay, this one is more on the fire due to fault currents. So protection against overheating, special requirements for air seating system, appliances producing water or steam. So they have done a lot of improvement. Dito sa internal assembly arc faults, it's required for assembly having a rated current above or equal. So merong mandatory requirements dito ng standard to 800 and maximum. Kaya kung mapapansin din natin sa PEC natin, meron tayong requirements na lagyan ng ground fault protection, yung mga above, if I remember, 800 or 1,200 amperes, yung mga protective device, because that is a protection against arcing, the effect of arc, which may result in fire. Okay, kaya meron ganon, yung protection na yon, ground fault protection. Okay, so prospective short circuit current greater than or equal to 25 kiloamperes. Okay, internal arc fault mitigation system shall comply with IEC TS 63107. Okay, these are additional measures. So hintayin na lang natin yung bagong standards. Probably the technical committee will look onto this one. What could be the advantage, yung mga improvements na ginawa sa ating mga standards. Okay, and lastly, I want to leave this one. Remember, sabi dito, it's always permissible to do more than the code requires. Yung code natin, we can do more than what it requires, but never permissible to do less than the code prescribed minimum. So this is already what we call substandard. So let's go on the standards. Kung ano yung requirements ng standards of the code, let's go at par, the same, yung requirements, or above the requirements. Let's not go below. Kasi hindi magiging safe yung installation. And katulad ng topic natin, this will always lead to fire. So I hope that you have received something here. Yung topic na ito is an overview. So malaking topic ito pag pinag-usapan yung details. So since it's just an overview, I will leave it up to the next speakers natin, yung detail. Doon mas more ma-appreciate natin yung requirements ng standard. So again, thank you everyone for listening. If you have any questions, then I'm ready to answer them. Of course, we have also technical panelists in our team now, the standards committee team. They are here to assist us. Of course, again, thank you very much and have a good day. Thank you. Thank you.
Thank you so much, Sir Conrad, for that very informative presentation. So we will now begin with the Q&A portion of our webinar this afternoon. If our panelists are available po inside the session, may we call them po Engineer Egbert Sales, Engineer Charles Singson, Engineer Armando Lanusa, and Engineer Edwin Pangilinan. Sirs, do you have questions to our speaker? Okay,
Probably
sirs.
the audience natin, probably there are some. who wants to clarify?
So far, sir, there are no questions in the chat
Okay then.
box.
Okay.
Yes, sir.
Oo. Kaya as I've mentioned a while ago, these are all requirements na probably hindi pa natin masyadong ma-digest, ano? Except for the fire. Yung prevention or electrical fires that probably we could more appreciate yung mga susunod nating mga presenters. So on that note,
Question, sir.
okay. Oh, yes. Yes, Mentor June, our
Yes, Sir
very
June.
here.
You may open your camera, sir.
I don't
Open
like.
your camera. Our National Treasurer. You're recognized daw po. Engineer June.
I'm mobile. But sir, how do we incorporate this or include this in the next PEC, sir?
Okay, that is a very good question to consider. While our code now addresses this protection for safety, and one of this is the thermal effects, probably the part of standards committee is to look deeper into this one, requirements of the standards. Then we are in the standards committee, we are recommendatory, no? Because nowadays makikita naman natin na most of our products now being installed, is all IEC based, yung mga standards. So we have really to study this one. We work together with our Philippine Electrical Code committee, standards committee, to really to have some sort of a what we call mga homegrown code, kung pwede sana na ganun ang gagawin natin. And we will check the relevant, whatever is relevant nowadays concerning yung advent of technology, yung advance ng technology ngayon, masyadong mabilis. So really we have also to look onto the our code also, that it will really be relevant and can meet the requirements, yung mga kwan ngayon, yung mga lumalabas nating mga products dito. And we will do that, Mentor June, as part of our mandate to collaborate, to recommend. Isa na to yung protection against fire, na makakwan ito, isama rin. Of course, we have the AFCI, which addresses also this one. But ikwan natin ito, pag-aralan natin mabuti para mapasama siya later sa ating code. Kung hindi man ngayon, probably sa future, but we will continue to explore the possibility to include all of these requirements in IEC. Okay?
Thank you very much.
Thank you.
Thank you very much. Very much appreciated, sir.
Thank you. Thank you, Natres June. Okay then. Thank you.
Thank you, Sir June. Thank you, Sir Conrad. So I think that ends, sir, our question and answer for the first topic. We would like to thank Sir Conrad for his answer to the questions. For any questions, you may reach out to our presenter via email. Any unanswered question will be forwarded to Sir Conrad, and please expect his response within 48 hours. Let us now proceed with the awarding of the Certificate of Appreciation. Once again, in behalf of IIEE, we will read, sir, the citation of the certificate. Institute of Integrated Electrical Engineers of the Philippines presents a certificate of appreciation to Sir Engineer Conrad C. Binondo, PEE, for imparting his valuable insights as technical resource speaker on the topic overview of PNS IEC Part 4-42 Protection Against Thermal Effects during the technical webinar entitled Standardization Challenges in Electrical Fire Prevention, held on March 6, 2024 through Zoom conferencing. Signed by Chairman IIEE Standards Committee, Engineer Conrad Binondo, Engineer Esperanza A. Collado, National Vice President for External Affairs, Engineer Joseph Darren, Claire S. Solicar, National Secretary, and Dr. Florigo C. Barona, National President. Thank you, Sir Conrad.
Thank you very much. Thank you, everyone. Thank you. Bye. Thank you.
Thank you, sir.
Thank you.
Additional reminders to our participants this afternoon. You can view again the recording for this session by accepting the webpage shown in your emails. Lastly, may we also remind everyone to scan the QR code that will be placed in the chat box to accomplish the form and survey questions. Your feedback is invaluable to us. Certificates will be sent to you after the session. We will now proceed to our second speaker. Our second speaker is Engineer Vic Christy Magdali, our professional electrical engineer with 18 years of experience in the renewable industry, focusing on energy storage systems and PV technology. This includes solar cell and module manufacturing and testing, quality assurance, technical support, commercial and power plant system design, and energy yield assessment. He is a former design manager of Solar Philippines and former senior electrical design engineer of Sun Power Global Electrical Engineering. He also worked on multiple megawatt scale solar projects in a global market as a technical support engineer, system performance analyst, and project engineer. Currently, he's an executive product manager of Huawei Technologies, which handles a smart PV regional competence center. He conducts market competitive analysis and participates in energy storage solutions and PV standard discussions such as IEC, UL, IEEE related to PV and ESS safety and grid compliance, and handles the standard and certificate compliance of Huawei Digital Power Asia Pacific and South Africa. He is the technical manager and owner of the VCTM Engineering and Design Services, working on the electrical system design of Citycore 2 megawatt Bataan Solar Farm expansion and PV design consultant of Infinity Solar Energy Solutions for residential and commercial designs. He is a project implementation manager of Amber Kinetics and currently involved in the Australia Gravitas 40 kilowatts 160 kilowatt hour flywheel energy storage demo. Once again, let's welcome Engineer Vic Christy Magdali.
Hello everyone. Can you hear me?
Yes, Sir Vic.
Okay, I'm gonna share my screen. Hold on. Please let me know if you can see my screen now. Kita naman yung screen ko, mama na. Hello? Kita naman po. Can you confirm from your side?
Okay naman, just enlarge it, full view.
Wait. Okay na, sir?
Okay, full screen mo na lang, naka-one shot. Full screen mo siya, hindi siya full screen. Nakikita yung mga sorter mo, slide sorter sa kaliwa.
Yan, sir.
Hindi pa.
Ayan pa rin.
Sir Vic, you can try resharing po your screen, sir. Yan, sir.
Okay.
Slideshow, then, yeah. Okay, nawala.
Vic, this is Paul. Can you hear me? Vic, this is Paul. Can you hear me? You're on mute. You're on mute.
Hello, Paul.
Hello?
So
Hello?
you go to your previous screen. Stay where you are. You were sharing the other screen, the presenter screen. Go there. Not this screen, the other one. Just now you showed. Don't go on the presentation. Go on the presenter screen. Yep. Just now you were flashing it up. The one with two small screen. Yep. Okay. Go to display setting. On the top.
Which one?
At the top, display setting in this screen on the top. Go up. Display setting. Yes. Go down.
All right.
Duplicate. You try and duplicate.
Okay.
And you
Got
try
it.
to share it now. Yep. Okay.
Yeah,
yep.
that's
It's good.
okay.
It's good now.
Okay.
Good to go.
Yeah,
Okay. Sorry about that.
good.
Okay. All right. So, okay, I'm gonna move to the presentation. Okay, so this is actually the contents of our discussion for today. So first of all, I would like to introduce share with you at least 5 topics for today. One is overview of the installation growth, particularly here in the Philippines and abroad. And number two is the safety hazards of solar PV systems. Number three, we will talk about existing AFCI and PB hazard control system or RSP standards here in the Philippines as well. And number four is implementation and operation challenges. So we'll talk about along the way recommendations so that if we encounter some problems with the same problems that we encountered before, then you know what to do. Okay. So let's start with this one. Okay. Wait. Okay, so as you can see here in this graph, since 2022, as you can see, there's only 28 countries that has greater than 1 gigawatt PV installation. So we're expecting that by 2027, would be goes around more than 100 countries. I'm actually showing some problem. Okay, so the drivers here is actually number one is the global and local policy. As you know, we have this climate change, green energy, net zeros. Number two is business opportunities. As you know, the PV is the I think the cheapest energy source right now. So we have this kind of like a trend. The next decade, we'll see more solar PV installations across the globe. So in terms of safety, okay. So safety, as you can see here, so many countries employs safety standards for rapid shutdown and AFCI. In Europe, I think they require if the solar DC or PV system are exposed, then you have to employ a rapid shutdown device. So in Thailand, we have also we see also a rapid shutdown device standards since July 2023. So China, they have also. So primarily USA and Canada, they employ rapid shutdown in FCI since 2014. Okay, so yeah, what are the electrical safety hazards of PV system? As let's see first the typical installation. So typical installation is mostly commercial, residentials. We have malls, campus, school campus, and some hospitals. So these areas are like very these are living spaces and populated areas. So some installations also are critical facilities like gasoline station, some are chemical factories. So we have those kind of safety risks on this kind of type of installations. So as you can see, there are some reported uh, fire problems due to solar PV. As you can see, in Australia, we have these issues as well. In September 15, 2023, and Italy, we have problem with DC arc faults. In Switzerland, so as you can see, due to arcing on the PV, we have this problem as well. Fire in the US, there's a lot. Although this one is the solar farm, I guess, but no, this one is a building also. So there's so much problem actually in PV system that we need to deal with. As Sir Conrad said before on the previous training or presentation, um, uh, IEC is actually requiring us to have the arc fault circuit interruption and should our installation should comply with the standards. So yeah, I want to share with you this actually problem in the Philippines since 2017. We've encountered actually, I'm not sure if you remember this reported fire in Cavite. It's actually in the factory. As you can see in the pictures, you see the PP panels there. Okay, PV panels here. So as you know, you can see here that the fire broke out at 6 p.m. So it's non-operating hours of the solar system, right? So my question here actually is that, what if this happened during operating hours of the solar? So I think the problem would be catastrophic. So as you can see here, so mabilis tong ano mag propagate yung ano natin yung fire if the cause of fire is DC or DC arc fault. So also some of my friends, one of my friends shared with me before the problem in Baguio. There's also a fire here, which is reported as the electrical fault of the PV system. It was not reported directly, like the cause of the problem is PV system, but it was reported as electrical arc fault problem. So this one is happening actually the fire due to PV system are happening not just outside the country, but internally here in our countries. It happens. Some are not reported, and I talked to one of the chief of fire in one town here in Cavite. Actually, they reported some DIYers who they respond to a fire event in one instance, and sometimes they don't want to report the fire incident due to solar because the problem is that they don't want to maybe parang they want to ayaw na lang i-report, so ayaw nila lang sense of responsibility, something like that. So it's it's like uh it's like it's happening, but no one is reporting, so that's why we have to be careful also with this one. So that's why as designers, practitioners, as electrical practitioners here in the Philippines, we must be aware of the danger or the hazards of the PV system. So we must, ask our practitioners to be aware of these hazards. Okay, so not just here in the Philippines, as you can see, in the US, we have a fire in Walmart. 7 Walmart stores were exposed to fire incidents caused by PV system from 2012 to 2018. So I highlighted actually the reports. So as you can see here, caused by poor installation, poor maintenance, the loose connectors, so wiring exposed. So they observe also sparking on the PV system. So yeah, so this one is from London. So as you can see, same root cause, loose connections of PV terminals. And they mention here the problem is actually the solution. The solution is using an equipment to extinguish a DC arc. So okay, so let's try to map the electrical fault in a PV system. So as you can see, these are the typical fault that we are encountering actually in a PV system. On the module side, we have this hotspot. The primary cause of this one is mga cracks ng mga solar cells natin. So I think the solutions here is we must be tingnan natin maigi yung natin, yung mga solar panels na in-install. So once na may crack yan, it could cause a hotspot actually. So if you have an existing solar system on your home or contractor kayo ng solar PV system, so we must conduct a regular like a thermal scanning on the PV system. And some inverters also has this active monitoring na kaya nilang i-monitor kahit outside remotely. So you can see the underperformance string, the underperformance modules. So it would tell you na may problem yung system natin. So why I'm saying this, hotspot is actually is a napaka delikado rin na problem, the factory defect na magkukause din ng fire. Kasi eventually kapag meron yung loose connection ng mga electronics na sa loob, mag-hit yan doon sa spot na yan, and the current will flow there. So magano talaga yan, propagate ng fire. So including yung mga MLPE natin. MLPE is module level power electronics. That includes yung microinverters, our rapid shutdown device, and the optimizers. So included yan doon sa mga tinitingnan din dapat natin kasi more on DC to eh. So sa cables natin, may encounter natin yung mga DC arc. So kapag may mga breakages doon sa DC cables natin, kakaproblema tayo doon sa arcing. And ito naman ay installation resistance kapag na-cut. So due to aging, ang problem nito is ground faults eventually. Kasama yan doon sa leakage current. So sometimes ang protection nito is more on the inverters, yung tinatawag nilang ISO, low ISO, and the other one is the RCD. So yan, so madami tayong mga protection na tinitingnan ngayon na super advanced na. So ang iba ay meron pang okay, so for this, sa terminal naman is may mga advanced tayo na protection na ginagamit ngayon. Yung mga contact resistance ng mga terminal. So, yan din nagkakos minsan ng fire, yung mga arcing natin. Okay, so gusto ko lang i-share ito kasi development ito nung nung PV system doon sa DC side in terms of protection. Since 2000, dinevelop ng SMA yung dual relay design. So protecting also yung sa DC side. And by 2010, meron na tayong RCD saka insulation resistance detection ng SMA naman. So 2010 to 2020 is meron na tayo yung AFCI kasi ang drive nito is the 2014 National Electrical Code sa US. So right now, most of the inverters actually as the parang complete na device side na protection. So as you can see here, we have the rapid shutdown function, the arc fault circuit interruption, meron tayo yung low insulation resistance detection. Now may mga advanced na ngayon is connector temp detection. Sa mostly on the DC side ito. Kasi ang malimit na problem is yung sa thermal na katagalan is due to aging nga, nagkakaroon ng mga loose contacts din sa natin terminals and nagkakos siya ng fire. So meron tayong PV string level disconnection. So before pag combiner box yung gamit natin, very difficult, parang monitoring lang yung ginagawa natin. Parang tinitingnan lang natin kung string yung problematic and then we do our kumbaga troubleshooting and maintenance. But now we can actually determine which modules, which string, and pwede natin siyang i-isolate pag may problema talaga siya. So ground fault detection, so yeah, we were moving on to the like a complete system protections on the DC side. So ang drive nito is, yeah, of course, drive nito is to avoid yung fire risk hazard yung ano natin yung PV system natin. Especially when we are installing it sa mga bahay natin, di ba? Yeah. And including kakaroon tayo ng ano ngayon, like PV system with batteries, so medyo mas complicated na yung system. So meron talaga dapat na drive to have a complete protections ng buong system natin. Okay, so let's start with so for this time, we're actually focusing more on the two protections. Number one is the rapid shutdown function and the arc fault circuit interrupter. So I will talk about more on the module level rapid shutdown or using the module level power electronics, which is the RSD, the optimizer, and the microinverters. And for arc fault circuit interruptions, we have to talk about the existing standards that we have in Philippine Electrical Code, in National Electrical Code, and maybe IEEE we can share as well here. Okay, so let's start with rapid shutdown device. So ano ba yung pinaka-purpose kung bakit meron tayong rapid shutdown device? Ang problem kasi talaga ng PB is dalawa lang. Ang pinaka-worst, I think for me, pinaka-worst or pinaka-critical. Number one is DC arcs, which causes fire. And number two is yung high voltage ng ano natin, yung DC side. So pag meron ka high voltage, that means very challenging yung ano natin, O&M. Yung maintenance natin kapag naglilinis tayo ng mga modules dyan, if the cables or the DC side that carries current are exposed, then definitely it's has a kumbaga hazard yan sa mga personnel natin, sa maintenance personnel natin. Number two is yung firefighting. So generally the rapid shutdown device is, before ang tawag nila doon is fire switch noong 2013, 2011, nung wala pang rapid shutdown. They require us yung parang isolation device lang to isolate, but they call it like parang fire switch lang before. So but during 2014, ginawa nilang rapid shutdown device. So ang purpose nun is to reduce the voltage actually ng, for example, on this kind of installation, kapag nasa bubong ka, tapos nagkaroon ng fire, and gusto ng firefighter to akyatin yung bubong, o parang side ng bubong na gusto nilang akyatin para mag-firefight. So gusto nilang i-reduce yung voltahe na ng DC side natin to a safe value, which is before 80 volts, in 30 volts. So ang primary purpose ng RSD is to really reduce the voltage. So ang impact niyan is actually doon sa maintenance natin, magagamit natin yung RSD device during maintenance and firefighting. Okay, so ano yung meron tayo sa Pilipinas ngayon? So sa PEC 2017, actually present na actually yung ano natin, yung rapid shutdown device. As you can see here, meron tayong requirement na sa loob daw ng ano natin ng array. So magsukat lang tayo ng 305 mm. So that would be inside array boundary. So ano ba ang limitation dito? Inside of that should be parang less than 80 volts. So that means Yung mga modules natin ngayon is around like 45 volts open circuit voltage to 50, sabihin na natin. So, kapag dalawa na niya, so that means kailangan mo na ng wrap RST. So, kapag siniris mo yung dalawa, so for example, itong dalawa, 45, 45, siniris ko siya, so additive siya. So, more than 80 volts na yun. So, kailangan mo na siya ng RST. Pag i-activate mo yung RSD, the inside boundary should have less than 80 volts in 30 seconds. So, yan. So, expose yung ano natin, mga conductors sa loob. Nasa ilalim siya. So, outside naman is 30 volts in 30 seconds. So, that means outside nung 305, pababa na yan ng buildings or yung mga exposed natin na conductors na pababa and nasa cable trays, conduits, should be 30 volts when we activate the RST. So, ito yung existing natin sa EC 2017. Alright, so ang challenge dito is right now is sinasabi diyan sa PEC natin na ang mga RSDs daw natin is listed. So what do we mean by listed? So it should be compliant or tested by a third party certification bodies like maybe UL, IEC, so BPS supposedly dapat sa Pilipinas, but I think we don't have a capability to test yung mga ano natin, mga RSDs. So sometimes designers could just follow yung mga certifications out sa yung mga regional standards or international standards. So what we have here in NEC 2023. So same thing, I think wala masyadong nabago dito, but as you can see, ang hinighlight ko lang dyan is ito, firefighters na lang. Before, ang 2017 natin ay sinasabi is responders, emergency responders. So it could be, medyo interpretation ay possible na hindi siya firefighter. So sa National Electrical Code 2023 ay specifically sinasabi na firefighters lang talaga siya. To reduce shock hazards for firefighters in accordance with 690.12. So, yan na yung bagong ano ngayon dito sa actually sa National Electrical Code 2023. So, pwede pa rin natin siyang gamitin. I think for me, pwede pa rin siyang gamitin natin during maintenance kapag maglilinis tayo ng module sa taas. And we want as yung mga maintenance natin ay safe, hindi ma-electrocute. So, yan, pwede pa rin gamitin for me. So, ang isa pang bago dito is meron silang tinatawag, binago na nila yung pangalan actually nung equipment. PV hazard, yung PV HCS or PV hazard control system. So, marami siya actually, PVRSE. Ito is in conjunction dito sa UL 3741. So, ito yung mostly, I think binabago natin yung ano natin, Philippine Electrical Code natin ngayon. So, most likely, ito yung i-adapt nila. Kasi alam naman natin na yung Philippine Electrical Code is like mostly copy sa National Electrical Code. So, we expect na ganito rin yung magiging provisions nung 690.12 natin. Okay? So, this is actually the UL 3741 wherein the 2023 National Electrical Space from. So as you can see, firefighters, more on ito yung mga protection. No? So, module level, yung MLP natin is under the PVRSE. Okay? So, module level. So, kasama na dyan yung ano natin, RSD device na available sa market ngayon and the optimizers as well as microinverters. So there are other ways actually to implement an RSD. So you can actually, kasi sinasabi na expose, more on the exposed conductors, exposed DC side of the system. So that would mean if you can actually enclose it and make sure na yung arcing niya is hindi siya lumabas, mag-cause ng fire. I think it's kumbaga, pasado pa rin siya sa standard. Kasi may mga options dito like number 6. So you have an option actually. So there are many ways actually to implement an RSD. But the trick is dapat i-maintain mo pa rin yung 80 volts, like Pag expose siya more than pag less than 80 volts, hindi mo kailangan. So, ano naman yung meron tayo sa IEC? So, some designers uses IEC. Sabi nila, actually sa Asia Pacific, sinasabi nila is not, the RSD is not required sa kanila kasi IEC yung finavalo nila. But, nung tininan ko yung IEC, ito yung nakita ko. So, maybe some experts here in IEC could correct me, but ito yung actually yung requirement nung yung 60364 part 7 712. Mention ni Sir Conrad kanina yung special locations which is solar PV. Pag binuksan mo yon, yung protection against electrical shock niya, ang number one na yung 712.410.101, sabi niya dan ay considered na energize yung system mo kahit enough mo yung inverter, yung AC side. So that would mean is may risk talaga doon sa DC side na kahit enough mo yung AC side niya, possible na meron ka pa rin, may voltahe pa rin yung DC side mo. So that 101. So 102, sinasabi rin dyan na on the DC side, ito na yung recommendation. Kapag in-interpret mo ito, parang RFB din siya. Kasi sinasabi dito, on the DC side, one of the following protective measures shall be used. Number one is double or reinforced insulation. So, ano ba yung double reinforced insulation? So, according dito sa 61140 ng IEC, so meron kang basic insulation, tapos may plus, supplementary insulation. O reinforced. Yan. So, medyo strict, mas strict pa nga ito kung titingnan. Kasi parang hindi siya nag-allowed ng like exposed DC side of the system. So, number two is either you design it doon sa ELB, yung extra low voltage natin, yung separate extra low voltage or protective extra low voltage. So ano naman ito? So actually dyan sa 414101, sabi niyan, for the use of cell or PEL protective measure on the DC side, the open circuit voltage max shall not exceed 60 volts. So mas strict pa to doon sa ano natin, sa NEC tsaka PEC, which is 80 volts. So I think all the standards na designers like IEC, we have Philippine Electrical Code, we have National Electrical Code, and this one to tell us the rapid shutdown is required kahit anong standard ang gamitin mo. Okay? So bakit ko siya sinasabi ngayon? Kasi minsan yung iba sinasabi na sa international standards hindi naman daw required. So but this one it tells us na rapid shutdown is required in every standards. So, ang ano lang dito, ang summary dito is we should limit yung operating voltage doon sa DC side natin at ELB. Or option natin is double insulate, which is I think very hard to i-implement sa pipe. Okay. So, this one is actually we play this one. Oops. It's not playing. I think hindi nag-play yung video ko. Wait. Let me stop share muna. Wait lang. Hindi ako sanay sa ano. Zoom. Naririnig niyo yung video ko? Sorry. Could you confirm?
Hindi po, sir.
Hindi ba? Hello?
Yes, sir, hindi po.
Hindi.
Your slide, sir, is in slide 17.
Wait, I'm gonna, I have a problem with that. Wait. Yan po, ma'am. Sorry. Yan po, ma'am.
Wala pong audio, sir.
Let me share. Where's the sound? Share sound. Okay. Let's try again.
Businesses in an effort to help the environment.
There you
Wala
go,
pa rin po.
sir. Meron na po.
I-team has discovered solar panels could be dangerous in an emergency. More and more families and businesses in Western Mass are using the sun to go green, installing solar panels like this one to generate power. But as these become more common in Western Mass, fire departments are faced with new challenges.
There certainly have been examples with power being backfed into systems that have killed firefighters in adjacent states.
The solar panels, while a growing trend, have proven to be problematic in an emergency. An NBC television station in Philadelphia captured this video of a distribution center covered in solar panels. The firefighters in this case were forced to stop fighting the fire due to electrocution concerns on a bright sunny day. Northampton Fire Chief Brian Duggan told the I-team electrocution is not their only concern. Cutting through the roof for ventilation would also take a lot longer.
As an example, in East Hampton, there was a ventilation hole cut in a roof. It took about 25 minutes to do it. This would elongate that time by approximately double.
It's a situation both Northampton and Springfield fire departments have been faced with. Gregory Garrison, the president of Northeast Solar, agreed to talk to the I-team about the issue. He says firefighters just have to pull the meter when they get there. That allows them to cut the power. He disagrees they pose a risk.
The only issue that remains for them is maybe ventilating the roof and trying to find the convenient way to ventilate the roof. Technology is continuing to advance to provide those solutions for us, but for right now, from an electrical standpoint, they pose no issues.
Springfield Fire Commissioner Joe Conant says even when power is cut, they have to assume electricity is still generating, especially on a sunny day. He says nothing will stop them if there's a life to be saved, but if it's
So yeah, I think that's that video parang self-explanatory siya. Like pag mayroong daw solar panel sa bubong natin, very hard yung firefighting natin, especially kapag during operating hours. So hopefully hindi mangyari sa atin 'yun. But yeah, that's why we have this rapid shutdown device to aid yung natin, yung mga firefighters natin during worst case scenario. So as you can see here, I have kapag inactivate natin yung natin, yung RSTs, using MLPE, marireduce natin yung voltahe natin up to some LPE has 0 volts, some are 1 volts. So ang standard lang naman is less than should be 30 volts, less than 30 volts. So that's the requirement. But most of these new technologies has this function na furtherly marireduce pa yung natin, yung voltahe up to 0 volts to 1 volts. So very safe na siya. So as I've said also, it can be used as well during maintenance kapag naglilinis tayo ng ng PV during sunny day siguro. So we have to push the RSDs, activate the RSD para safe yung pag-akyat natin. Okay?
lots of people.
Okay, so ito isang videos. So alos
A warning tonight.
So same din siya, same principle. So ang suggestion talaga ngayon is the both standards of IEC, National Electrical Code, and PEC. Hopefully yung upcoming PEC natin should follow yung National Electrical Code that would tell us na kailangan module level na yung natin, yung protection sa RSD side. So hindi bawal na yung string. Kasi dati before 2014, I think string lang yung ginagamit eh. So that means pwedeng more than pa din ng 80 volts yung inside boundaries natin. Alright, so yan, as I said, most of the installation natin sa bubong, especially sa mga buildings natin, kailangan i-reduce natin yung voltahe. by using rapid shutdown. Okay. So gusto ko lang i-introduce ito, yung MLPE, which is actually my highly recommended na device to use as an RSD. So number one is the microinverters. So I think mayroon tayong mga known brand. It's a part of the parang electronics din na nilalagay natin sa bubong na asana natin sa each panel natin. Or sometimes mayroong microinverters na 2:1. So ang trick lang dyan is dapat ang voltahe ay less than 80 volts inside. So power optimizer, ito double purpose na siya. It can optimize the production of your array, especially pag may mga shading and yung mga mismatch doon sa factory ng panels. So you can optimize the power and as well as you can use as an RSD as well. So I think yung pinaka known dito sa atin parang ginagamit is yung RSD na parang RSD device. Na ito is meron siyang controls na nilalagay din siya each module or may 2:1 din, and then mayroon siyang parang ina-activate to reduce the voltage to safe value which is 30 volts. Okay? So ito yung sample actually ng isang system na merong optimizer. I use the optimizers. Ang ano lang nito ay, as you can see, kapag inactivate mo yung yung voltahe mo, inactivate mo yung RSD sa inverter, so in-off mo yung DC side or yung AC supply ng inverter, automatically yung DC cables mo from inverter to the optimizer would goes around some optimizer has 0 volts, some are 1 volt. So say for example for this one, I think ang suggestion ko dito ay go with the 1 volt system kasi ang problema ng 0 volts sometimes kapag nag-test tayo, hindi natin alam kung gumagana siya o hindi. Okay? So kasi kapag nag-test ka pag open dito sa kabila, dun sa may PV panels going to optimizer kapag open, so technically may problema ka pala sa installation, hindi mo alam kung may problema, kung tama yung connection mo. So, mas okay na meron kang ma-measure 1 volt, at least 1 volt. So, ang standard naman is 30 volts. So, yan. So, using optimizer actually is napakadali niya kasi just off the inverter and you activate the RSD. So, safe ka na. So, usually, ang mini-maintain dyan ay itong 99.6 volts. Ito, medyo hindi na siya pasado. So, we should maintain less than 80 volts. Okay? So, next one is the microinverter. So, simple lang yung microinverters. Actually, one panel, may isang microinverter. So, pag inverter ng kinabit mo sa bubong, so that means, ang paglabas nun is AC electricity na siya. So once you off the AC supply dun sa mga distribution board natin, then definitely yung wire mo from the distribution board going to the microinverters, yung AC side mo would be 0. So safe ka pa din. So kung alam natin na yung panel natin is around like 45 to 50 volts open circuit voltage, so that's lower pa rin. Okay? So, ito naman is ito yung I think very common dito sa atin sa Pilipinas. Yung separate RSD device. Hindi siya optimizer, hindi rin siya microinverter. Power electronics lang talaga siya to reduce the voltage actually ng module natin. Sometimes ang iba is 1:1 and 2:1 din ang iba. So, ang critical dito is we should maintain yung 80 volts. For example, this one, ang inside array dapat natin is 80 volts. So that means, kapag 2:1, be careful na lang tayo kasi hindi siya minsan pumapasa doon sa 80 volts. Kasi pag dalawa na siya, pag 45, so that would be 90. So, kung maging strict tayo, so yung 2:1, mukhang hindi siya papasa doon sa standard. Kasi nagano ka dito. Okay? Or unless you measure each one could be dapat less than 80 volts siya. So, ang way naman nito is to activate, meron kang push button dito. Sometimes, ang challenge naman dito is yung sa communication, sometimes nagkakaproblema. May mga additional components tayong ina-add like power supply, may auxiliary supply pa na 220 volts. So unlike this two, yung optimizer tsaka yung microinverters natin, parang plug and play na lang sa inverter na yung function ng RSD natin. Alright, so ano yung mga challenges ngayon dito sa Pilipinas? Actually, ito yung mga na-encounter na namin. Na-encounter ko personally dito sa Pilipinas na mga nag-share din sa akin ng mga problema nila about sa RSD. And some people are, especially yung nasa business side, ay nagsasuggest na tanggalin na lang daw yung RSD sa natin sa standard. Ako personally hindi ko talaga siya recommend na tanggalin. Kasi it could be that the problem is the product itself. So minsan dun sa installation problem din natin, so mga unskilled tayo na technician na nag-install and hindi masyadong clear. So meron tayo dapat na like on our side sa standards committee and sa BPS naman sa mga working group sa BPS, we're trying hard na magkaroon ng parang basic na like guide, application guide or installation guide or commissioning guide na magagamit ng mga installer natin as well as the inspectors. So some of the problem na-encounter and na-share sa akin is sometimes ito ingress protection issues. Dinideclare nila na IP68 but in reality may mga may mga spaces eh. So due to aging siguro nagka-crack yung mga parang plastic na ginagamit, diba? HDPE lang siguro ito. Nagka-crack yung mga connectors niya. So along the way sa abang tumatagal, kakaroon ng mga gaps. So pag nagkaroon ng gap, syempre expose sa araw at init, and then kapag umulan napapasukan ng tubig. So yun na yung cost ng arcing mo. So sa halip na makatulong siya for fire, siya pa yung naging cause ng fire. Parang yun yung complaint sa amin. So thermal events, so overheating naman. So as you know, yung RSDs, mga power electronics natin is in-install natin sa likod ng PV panels natin. And sometimes nakadikit siya doon sa bubong na sobrang init. So kaya nasusunog. So makikita nyo itong module na to, ilagay yung RSD dyan, nakadikit sa bubong, so uminit ng uminit. So ito yung nangyari sa kanya. So some people also point of failure pa siya and fire hazard. So nagiging cost siya. Ito yung mga issue dun sa product quality. Sa testing and commissioning naman, some very challenging yung pag-test ng mga module. Kasi ang ginagawa minsan, in-install na muna nila yung mga pag nag-string test sila, hindi nila ma-string test. Very hard. Kasi individual siya, so hindi nila, kumbaga, kasi may mga instance, yung mga electricians are known dun sa mga string site. Like 10 modules per string, measure nila yung open circuit voltage, short circuit current, so mga ganun. So very challenging daw. So monitoring communication test. Ito, iba-iba yung technology na ginagamit ng mga RSD suppliers natin. So wala tayong standards kung ano ba talaga yung maganda. May mga added requirements, may additional AC supply, kailangan ng 120 volts. Ang iba, kailangan ng UPS para activated pa rin daw siya pag nagkaroon ng fire tapos walang grid. So mga ganun. Tapos ito pa, isang problema. Kapag yung system natin ay mayroong arc fault circuit interruption, nagkakaroon ng interference nagkakaroon ng itong RSDs natin, nag-generate siya ng noise. And napagkakamalan nung EFCI natin na arc. DC arc siya. So nagko-fault yung DC arc. So kapag nag-fault yung DC arc, i-off niya yung inverter. So that means affected yung production mo. Okay? So some standards challenges natin dito na wala tayo actually. So sometimes ito, no sizing guide. May na-encounter ako, nagkaroon ng problema sila na nasunog yung RSD. Nung in-investigate namin is undersized. So 2:1, tapos ang capacity ng RSD mo is 1,000 lang, 1,000 watts. Tapos in-installan ng 550 modules, 550 watt modules. So kung dalawa, di more than na siya. So Ito, yung sizing guide. So, ang iba naman is 440 watts na, no, na 1:1 na RSDs, ininstall ng 500 watts. So, yung mga ganong scenario, I think wala yan sa, ano natin, sa PEC, yung sizing ng RSDs and this kind of electronic device na ginagamit for RSD. So, ang challenges din namin sa standard committees ay ito may mga kailangan tayong i-adapt na mga standards na makakatulong sa mga designers natin to further kumbaga strengthen yung ano natin RSDs na implementation natin. Ito, marking and labeling not implemented on site. Ito, malimit to nakikita ko. Ang tatandaan lagi natin na yung RSD is for firefighters siya. So, parang ano din yan, parang fire switch na hinahanap ng mga fireman natin kapag may fire, di ba? Kailangan visible yan lagi dapat. So, yung iba nakatago. So, ang iba disusi pa. Talagang ayaw ipagalaw. So, kailangan mayroong proper na ano yan. Sa Philippine Electrical Code, meron niyang recommendation kung saan dapat siya nilalagay. Alright? Okay, so ito ay isang testing example lang na ginagawa namin sa site. Using yung optimizers and microinverters. So dapat kapag nag-off ka ng AC supply ng inverter or DC supply ng inverter, supposedly dapat yung mame-measure mo na voltahe doon sa pababang conductors from rooftop going to the equipment ay 0 volts siya or below 30 volts dapat. Okay? So kung sa taas ka naman magme-measure, so dapat doon sa inside array should be less than 80 volts. So ito yan, parang sample lang. So yun nga, suggestion ko is magkuha siguro kayo ng type ng ng RSDs or optimizer na mag-generate ng at least siguro 1 volt para malaman natin na gumagana yung RSD mo o hindi. Kasi pag 0, baka magtatanong ka pa na, ay baka hindi ko na-connect yung positive negative dun sa module. Diba? So mas okay kung may voltahe. So ito yung mga suggestions na pwede nating i-include dun sa mga application guides na plan na gawin ng IIEE and sa BPS din siguro. Okay? So market readiness. So I think since 2019, since implemented na yung RSDs, I think most of the known brands ng inverters and suppliers ng mga ganitong device ay meron na tayo sa market. So kailangan lang tayong pumili ng mas maganda siguro, and since na we're still working on the product listing siguro sa BPS, wherein we can actually list down all the approved products for RSD. So, as a designers, as an electrical practitioners, unahan na natin ng maayos na pagpili. Like yung technical specifications natin, dapat naka-based doon sa standards. IEC man yan, or National Electrical Code man yan, or PEC man yan. Okay? So, these are some of the recommendations na in summary doon sa terms sa rapid shutdown. So, tatandaan lagi natin na yung rapid shutdown device or PV hazard control is required by all standards. So, it makes firefighting safe, and ito yung primarily na nakikita ko na importance niya aside from the firefighters. Sa module cleaning, so kailangan safe tayo dyan. Pag umakyat tayo sa bubong, huwag nating hayaan na akit yung mga personnel natin na hindi natin nila-off or nire-reduce yung voltahe doon sa taas. Delikado yon. Okay, so pag nag-roof maintenance, pag may mga kailangan, so ito yun. So, ako personally, I would recommend yung MLPE. Huwag nang tayong gumamit ng string level RSP or combined. So, sa standard committee naman ay proposing yung mga yung testing guidelines. Tsaka installation guidelines siguro dun sa manual, and sa working group namin sa BPS sa IEC, we will try to create application guides as well. Okay, so next up, yung topic natin is, sabi ko nga, DC high voltage, yung problema ng PV system. The second one is the DC arc. So, ang problem ng DC arc is actually this one. So, kapag nagkaroon ng arcing dyan, DC arc, so ganito yung itsura niya, para siyang posporo. So, yan. So, So what is really an arc? So an arc daw is a glow phenomenon caused by the ionization of the air. So for me, siguro ang pinaka-simple terms lang is kapag 'di ba nagta-touch tayo ng ano ng live components ng conductors, nagkakaroon ng spark, 'di ba? So maglagay ka lang ng pinaka-konting space na nag-flow pa rin yung current doon sa area niya. Sa in between, like very small, like this one. So mag-generate talaga yan ng arc. So kapag continuous yung ano niya, yung flow ng current, ang problema kasi nito is different siya dun sa arc plus kasi ang arc plus talagang one time siya, napakalakas ng density, ng energy density niya. So mag-explode. Ito is very low intensity but continuous siya. Continuous discharge ng current dun sa electrical fault, dun sa point ng electrical fault. So magkakos siya ng fire. So yeah, according to this study daw, as you can see here, nag-investigate sila ng rooftops. I think this one is from 2008 to 20 something. So ang 75% ng fire na yung PV system naman nagkaroon ng fire problem, ang 75% of that is on the DC side. So that means ang problem talaga doon is yung DC arc natin. So as you can see here, yan, ignition caused by PV module. So ito yung sinasabi ko kanina, yung mga hotspot, yung may problema sa junction box. Number 2, isolator. Before we use yung parang string combiner box na may isolator. So due to aging, kakaroon ng mga arcing dyan. Combiner box fuse. So ignition caused by cable. So pag may mga rat infestation, may pest infestation, kinakagat yung mga insulations natin, and expose siya, ground fault man siya, or may nag-separate man siya, nag-cut, so magkakaroon siya ng arcing. So 75% daw ng fire problems caused by the DC side of the PV system. So ano ba difference ng DC arc sa AC arc? Kasi ang PV system naman is compose siya ng DC at AC side, di ba? So, from here, actually, as you can see, dito pa lang sa graph natin, kapag nagkaroon ng DC arc, ang DC kasi wala yung, hindi nagpupunta sa zero, di ba? So, that means, kapag nagkaroon ka ng arcing sa DC, continuous yan. Wala yung time na mag-off siya ng konti. Unlike sa AC arc, naturally siya extinguish kapag nawala yung hihina siya. Okay? So from this diagram, actually ang sinasabi lang dito ay mas delikado yung DCR. Yes, mas mabilis yung propagation niya to fire. Okay? So ito yung sample actually. So ito yung mga magandihan. So ito yung mga reported sa amin. Actually ito yung mga na-receive from the customers encountering some arc faults sa mga sites nila. So don't worry, itong mga site na to ay hindi naman sa Pilipinas dito. So kinuha ko lang siya before para ma-introduce sa inyo kung ano yung danger ng arc, yung DC arc natin. So makikita nyo dyan, continuous yung arcing niya, di ba? So yan. Kung ito, imagine mo nasa bubong yan ng bahay ninyo. Ganyan yung nangyari. So definitely meron kang may nagsindi doon sa taas ng bubong. Okay? So ito namang isa ay problem naman from ito thermal effects naman to. Ang cause nito is more on the cable sizing. So nagkaroon ng overheating doon sa cable trays. So DC arc pa rin ang problema nito. Okay? So ito naman, nakita niyo yung aftermath nung natin, yung problems natin kapag nagkaroon ng problema ng DC arc fault sa PV system. So sunog yan. So kaya niya actually butasin yung bubong. So yan. So pero wag kayong matakot to install the solar PV system on your roof. You have to be aware lang kung ano yung mga safety hazard and kaya nga meron tayong RSDs, meron tayong arc fault circuit interruption. So, nilagay sa standard for us to be safe and mawala yung risk ng fire natin. Okay? So ito naman, I put here actually the parang equivalent circuit ng solar cells natin. So it tells us lang na kapag merong araw at their operating hours ng ng PV, kapag nagkaroon ng arc fault or DC arc fault continuously, magana yan, kumbaga tuloy-tuloy yung natin, arcing natin. So ito yung mga three common causes of DC arcs. So number one actually is yung junction box ng mga modules natin. So, kaya very critical yung pagpili ng magandang klaseng module. Hindi po yung yung pipili tayo ng mga substandard na module. So, BPS, yung Bureau of Philippine Standards, meron na tayong mga na adopted standards for PV, yung sa product standards natin ng PV. So, check natin 'yan. So, kailangan pag tayo ng module, pumili tayo ng module, dapat pasado siya doon sa natin sa mga product standards na meron tayo. So number 2, yung connectors naman. Ito, malimit itong nangyayari. Ang pinaka-cost talaga nito nakikita ko is yung improper yung crimping ng mga MC4. Ang iba gumagamit ng improper tools like plies na nga lang yung iba eh. So very siya. Ang iba naman ay hindi gumagamit hindi compatible yung connectors. IEC recommended yung PB type 4 connectors sa PV side natin. Okay? So number 3 is yung DC cables natin due to aging. So nagkakaroon mga cuts na yan. So yan, mag-art talaga yan. So ito naman ay from IEC. So as you can see, ang arc daw ay can happen doon sa series, yung natin, halimbawa, positive home run, nakat yung gitna, so naputol, may space up in between, abot yung current niya, so that means mag-arc yan. So meron din tayong tinatawag na para line to line na arc. Ito, very dangerous din siya, but sometimes very unlikely siya mangyari. So, and ito, kapag nangyari ito, may protection tayo lagi, di ba? Nagre-require tayo ng OCPD sa natin, sa inverters, sa DC side natin. So, line to ground. So, failure ng insulation. So, itong tatlo na to, ang pinaka-common actually dito na arcing is yung series arc fault. Yung mga contacts ng yung conductor to conductor, or kumbaga, conductor to conductor, yung conductive na element natin. Like cables, kapag may breakage ka sa cables, yung series niya dyan, magkakaroon siya ng arcing. And terminal din, ng inverters, arcing din yun. So 80% daw, according sa study. So anong meron tayo sa Philippine Electrical Code? So electrical codes, actually 2017 ay meron na tayong arc fault circuit protection, direct current. So yung direct current, particularly sa PV. So hindi to tinanggal. Actually yung sa AC side, sa PEC 2017, I think tinanggal yung AFCI eh. So, but sa DC side, sa PV, ay hindi siya tinanggal. Andyan siya. So, required talaga ito since 2017. So, dapat lahat ng installation natin ay merong arc fault circuit protection device. Okay? So, sa IEC, ganun din. So, sa IEC naman ay, although sinabi, yung minention kanina about sa RSDs, same thing. So, ELB dapat siya. Tapos, meron tayong arc fault protection equipment, itong 63027. Ito naman ay yung pag-test ng arc fault protection equipment. So, meron tong standards kung paano mag-test to. Re-require din ito sa IEC. So, ito actually requirement sa pag-test sa lab, sa laboratory. So, at least daw 2.5 amperes ng current at 312 volts. Open circuit 480. Ito yung mga separation. So, dapat under this condition, mag-trigger yung arc fault detection mo. Okay? So, mamaya may papakita ko sa inyo yung mga testing na ginawa ko actually personally sa ibang bansa for testing and as well as din sa Pilipinas for this one, 6007.
Vic, excuse me, Vic.
Yes, sir.
Yes, paki-wrap up na lang kasi nandyan na yung isang speaker.
Okay.
Okay, thank you,
Okay.
thank you. Okay.
Okay, sir, thank you. So for UL naman, those are using National Electrical Code. Ito rin yung standard. So halos same din siya nung sa IEC. So this is actually the one of the testing na ginawa na procedure na ginagamit ko for arc fault circuit interruption testing. So we have this IEC design arc fault generator. So maybe if you're interested, just let me know para ma-explain sa inyo further.
Right, good.
So this is
Just
the
a
test,
test regarding
sample test.
safety. I've currently
This is sample test that I did sa South Africa. So using the UL arc generator.
set up a spark generator, and as you can see, it acts.
So as you can see here, sineparate lang namin yung positive foam run. Kinat namin and insert namin to in series dito sa arc generator. So you can see yung arcing niya. So ganito yung mangyayari sa inyo during arc fault.
You have
Okay.
set it now.
So these are the solutions na existing ngayon. Yung kumbaga separate device meron din. And then meron yung built-in. Usually karamihan ng mga known brand ng inverters ay built-in na yung AFCI. So some challenges na encounter natin ngayon sa kumbaga yung effectiveness ng AFCI on site. Sometimes merong limitations yung natin yung mga AFCI natin ngayon. Sa standards sa UL is around 80 meters nung length nung natin nung cables. And sa IEC naman is around mababa lang din. So around mga ganyan sa test na test ko is around 60, 80 ganun din. So pag more than that hindi na reliable yung AFCI detection natin. So anong ibig sabihin nito? So that means kapag mga residential homes and small commercial, we should maintain yung mga cables distance natin na siguro around 80 meters, 60 meters lang. Kapag beyond that, may na yon, kumbaga may challenge na sa detection ng AFCI. So same thing. So I think we can, if you want, I can discuss this further. Just let me know. So in terms of readiness, sabi ko nga ay available naman sa market yung mga AFCI devices natin. So you just have to choose lang kung ano yung mas appropriate sa installation. Alright, so some recommendations. Mostly sa standard committee, we're trying to have a PB manual. So we will include this siguro doon sa natin, yung mga guidelines, application guides nung natin yung regarding AFCI. Okay, so that's the end of my presentation. I am ready to answer some questions.
Thank you, Sir Vic, for that very informative presentation. In the interest of time, sir, we are very sorry, but we would love to hear more from you soon in our next discussions. Now is the portion of our question and answer. We would love to answer some questions from our viewers if there are. You can put it po in your chat box. Okay. I think there are no other questions, sir. If you have other questions later, you feel free to reach out to our committee or to Sir Vic. I think he will be staying pa later po in the session. Okay. Any unanswered question will be forwarded also to our author, and please expect his response within 48 hours. So we will now proceed with the awarding of our Certificate of Appreciation. All right. So I'll read the citation of the certificate. The Institute of Integrated Electrical Engineers of the Philippines Incorporated presents the Certificate of Appreciation to Engineer Vic Christy Magdali, PEE, for imparting his valuable insights as technical resource speaker on the topic arc fault detection and hazard control in building integrated PV system during the technical webinar entitled Standardization Challenges in Electrical Fire Prevention, held on March 6, 2024 through Zoom conferencing. Signed by Engineer Conrado C. Binondo, our chairman for IIE Standards Committee, Engineer Esperanza A. Collado, the National Vice President for External Affairs, Engineer Joseph Darren Claire S. Solicar, National Secretary, and Dr. Florigo C. Barona, National President. Thank you so much, Sir Vic. Once again, in behalf of the IIEE Standards Committee, thank you so much, Sir Vic, for your presentation. We would like to thank everyone for your active participation in this session. I can see so many participants clapping, sir. Okay, some additional reminders. You can also view the recording for this session by accepting the webpage as sent to your emails. And lastly, you may also remind to accomplish the form in the chat box set by Ms. Micah for your survey questions and for your details of the certificates. So your feedback is valuable to us. All right. So I think there are some questions in the chat box later set po ngayon. So we will be answering them via email already. Okay. Moving forward, we will go to our third presenter. She online already?
Hello.
Ay,
Should
hello.
I?
Okay.
Hello,
Good
I am.
afternoon, sir. So our
Good
speaker
afternoon.
holds an engineering diploma from NSAM and from Supelec with 20 years of experience in research and development for electrotechnical devices, including design, laboratory, and project management. He's a standardization manager and involved in IEC and Shenelec standardization bodies, focusing on product standards and installation standards. We are very much delighted to welcome Engineer Jean-Francois Ray to present to us the topic on protection against thermal effects in electrical installations, recent breakthrough in technical and standardization. Good afternoon, sir, from the Philippines.
Good afternoon.
We're very excited to listen from you today.
Hello.
You may share your
I will share
slides,
my
sir.
screen.
Yes, sir.
I will share my screen. Hope you can see my
Yes, sir.
screen.
You can flash it already. Presenters, yes, correct.
Is it
All
working?
right.
Can you see
Yes, sir,
correct?
it's working and your audio is okay. Thank you, sir.
Okay, very well. So thanks a lot to invite me. I am very pleased to present you our work in protection against thermal effect in electrical installation. So I am involved at IEC level, and I will more focus today on AC installation and the risk of fire. So this is my picture. I have been introduced, so this is perfect. We can move on. So I will speak today about sorry, I will speak today about. I want to start with a real dramatic event which took place in Spain. So it's in Europe. So I am European, and it's not far away from France, where I am from. And there was a fire in a building. It was a high-rise building with 140 apartments. This occurred 2 weeks ago or 3 weeks ago in February. Even if the movie is saying that 4 people were killed, in fact, it seems that 10 people were killed. The origin of the fire is still under investigation. However, it is likely to be a short circuit in the the motor of a patio awning, and this has completely damaged the building. So this shows, and this was an electrical fire. So this shows how electrical fire can damage buildings. So in fact, there is something which is on my screen. Okay, which I will move here. Okay. So today I will speak about electrical fire as a major concern in buildings. I will not focus on DC. It will be mainly on AC. We will have an overview of root cause of electrical fire and existing protective measures. We'll speak about electrical arc, and I am very happy to see that just before me somebody was speaking about electrical arc, and I think that's really an important issue. And we'll speak about the recent breakthrough in technology, and we will speak about the update of installation standard to reflect the state of the art. So if we start by the first point, electrical fire. So first of all, I made some researches recently, and the consumption of electricity between the 70s and the year 2010 has doubled in, let's say, in the countries where we could find some figures. So I would say in mature countries. So on average, the consumption for electricity was 5,000 kilowatt hour per year per capita, and it doubled to 10,000 in average in the year 2010. So this means can really double the value, and probably this will continue. So this is extract from a document I published. So when we speak about energy transition is very often understood as electrification. So this means increase of the use of electricity in the infrastructures, in the building, in the industry. So this is really where we are going. So we can still expect again an increase of the use of electricity. Then, if we look at the situation, and I have 3 examples to share with you, I was really struck by a fire which took place in June 2017. This was in London, a tower, a residential tower. 72 persons were killed. It was a tower, high-rise building of 100 flats. And the source of the fire, the origin of the fire was electricity. It was an electrical fire. In fact, it started with an appliance which started the fire, and then the fire was really a big fire due to the cladding of the building. But at the origin, the fire was an electrical source. Another example, in India, this time, it was a training center. Again, an electrical fire in this training center started. It was in 2019 in one of the states of India, and 22 students were killed by this electrical fire. And another example, in Algeria, again, electrical fire in a nursery. 8 babies were died due to this fire, and this really shows that the consequences of fire. This is, I will speak about that later. The consequences of fire depends also on the ability of the people to escape, etc. So all these fires have to be analyzed, and the places and the circuits and the building to be protected depend on the application of the building. But we will see this later on. So if we look at the fires in number, so those figures are covering Europe. It's but I think it reflects the situation. So 2.2 million fire each year in Europe, causing 4,000 deaths, 100,000 injured persons. But when we speak of fire, there are many causes of fire, many type of fire. So I am more interested in building fires, and you see on the right hand side of the graphic that roughly 50% of the fire are fire in buildings, and then you have fire for grass, fire in forest, fire out of building, etc., etc. But let's say 50% of the fire are in buildings. And important information also. So the cause of fire by electricity is between a quarter and nearly 40%, depending on the country, depending on the calculation. It's not so easy to find exactly what is the proportion of fire which is of electrical origin. But let's say if we say 25% to 30%, this is really a common figure which is shared by many in many countries. And if you read a publication on that, you always find those figures. So let's say at least 25% of fire are caused by electricity. Therefore, it's an important topic that we have to address. If you look also at the number of fires, so this graphic, unfortunately, it's only a limited number of countries, but this is really figures that we found country by country. But if you look at this graphic, you can see that the number of fire, it's a number of fire per million inhabitants. It does not appear on my graph, but it's a number of fire per million inhabitants. Therefore, you can compare the countries. And you can see that it remains relatively stable. In fact, it moves a little bit, but it's relatively stable. It does not decrease. And it's also interesting to compare with another topic, which is electrocution. And the number of electrocution per million inhabitants in the country. So I have USA, Germany, France, UK, Spain, Norway. It decreased. It has been divided by 4 in the past 30 to 35 years. So really a sharp decrease. And today we are at a level which is quite low. And which, however, because I believe we took care of electrocution, and electrocution is really something everybody has in mind when using electricity, but fire still needs to be improved. This is why I compare those two curves, and I really believe that there is still some progress to be done on electrical fire in buildings in general. So we have seen that those fires are a major concern. So now let's have a look at the root cause of fire and the existing protective measures against electrical fire. So back to the basics, what we call the triangle of fire. You need, but most of you probably know that, you need heat, fuel, and oxygen. If you have the 3 elements, you can start a fire. If one of the side is withdrawn, then the fire stops. So you either you remove oxygen, you remove heat, or you remove the fuel. This is a classical explanation of fire. Related to the root cause of fire, there is a technical report IEC, from IEC 63054, which lists, let's say, the most common root cause of fire from the, let's say, the most frequent to the least frequent. And we can see that the poor connection, the arcing across a carbonized path, or the arcing in air are at a quite, let's say, frequent level. Therefore, those root causes have to be addressed. So an arcing in air. So this is something which is important to be assessed. So IEC TR 63054. This is one of the graphics in this technical report. Of course, there are some very well-known protective measures, circuit breakers or fuses to protect against overload and short circuit, which can eventually create a fire. Another element, result current devices of 300 milliamp protect against insulation failure, which can create a fire. Maintenance, of course, which is quite well known to verify periodically connection, is something, of course, which is of importance. But I want to focus on something which is a bit new today, is electrical arc and how electrical arc can create a fire. So this video I will show is maybe I should not put the sound because okay, like that. So this video has been made with a high-speed camera. So we did that in our lab, showing how a damaged cable could create an arc. So here, the damaged cable, the current flowing in the cable is around 8 amps, and we can see how very rapidly you can create an arc, and you can create a fire. The other video is not. It's a simulation. It's not really. It's just to explain the phenomena. I can show it, but the first one for me was more interesting because it was really showing what happens. This second video is more showing how a parallel arc can occur and how this parallel arc can damage the insulation and start creating a path through the carbonized mass, which will finally create a fire. So these are the two aspects of electrical arc: series arc and parallel arc, which both of them can create a fire. So, how to detect the dangerous electrical arc thanks to breakthrough in technology? So now we have seen that we may have dangerous arc, and we need to detect it. So this is again something we did in our lab. It's really just to explain how it can happen. So you have a fan, a heating fan, supplied at 230 volts, with a circuit breaker and an RCD, and we have created it just here, a kind of bad connection, and you will see how this bad connection can quite rapidly create. So you can see that we start the fan, and it's a 1000 watt fan without arc fault detection, and you can see really that you can quite easily create an arc with some flames, which could start burning the surrounding of this conductor. So, just to understand what is the physical aspect of arc. So, what happens in the previous case? So, electricity is flowing in the conductor. So, this is a series arc, obviously. Electricity is flowing inside the conductor. You have a damage due to the damaged conductor. You have a kind of bottleneck, and the density of current flowing in this part becomes really higher. The copper becomes hot and oxidized, and the insulation carbonized. And you have carbon here in this phase 3 and phase 4. And then the copper melts, and therefore you have a very small air gap. and you have some small sporadic arcs coming inside this air gap with a temperature which can be up to 6,000 Celsius degree. And then you have a stable arc, because this is also important, because you may have sporadic arc which are not dangerous, but what is dangerous is a stabilized arc, and this is what we will see later. And then you have a stable arc across carbonized paths, and this stable arc brings a lot of energy and can start burning. So this is really what happens with arc in electrical installation and in conductors. Usually we say that you have the following phase. First of all, a charring phase, which can be quite long with quite low current, and it's a kind of glowing which predominates. And then you have an ignition phase, which is very short, and then you have the first flame which appears. And we have noted also that the glowing predominates, let's say, at below or at a level of 2 amps. So then how to detect this? Detection of such arcing can be done by measuring several parameters: the voltage, the current, and the noise, the high frequency noise which appears. So if you look at the current, for example, the load current which will flow inside the load, you will see some interruption at zero crossing of the current, because you have no current flowing and then starting again. So you will see those kind of small shoulders. On the voltage, on the measurement of the voltage, you will see such a phenomena that we call shoulders, because due to the presence of the arc, the voltage remains stable. And if you look at in the frequency domain, you will see quite high frequency noise due to the presence of arc, because you have multiple small arcing occurring during this period. So technology, in fact, so technology measures all the parameters I've spoken about. So basically, and depending on the technology, and you have one or several current sensors, you have voltage measurement, and thanks to the various current sensor or residual current sensor, depending on the technology, voltage measurement and current measurement, and due to signal processing and digital conversion, measuring current wave shape, high frequency content, voltage levels, and specific algorithm and data processing, it is possible to ensure a tripping signal, and this is what we call arc fault detection device, AFDD. Which is also, of course, the similar technology as AFCI, arc fault security interrupter, which is well known on the North American market. And AFDD is, let's say, standardized at IEC level with IEC standard. There are quite a lot of devices available on the market. I have shown several examples of this technology from many very well-known brands like Eaton, like Schneider Electric, like Siemens, like ABB. So really, and there are plenty of other devices. Again, those devices are intended to be used for AC supply, and this is really for AC application. And so those devices are available on the market for sure. So there is an international product standard defining what is an arc fault detection and protection device, so-called named AFDD. The product standard is IEC 62606, which defines several types of devices which can be, maybe I can show with my pointer, which can be either a standalone AFD unit with its own opening means, or an AFD unit embedded in a existing protective device, like a circuit breaker or a residual current device, or you can have also AFD unit intended to be mechanically coupled with another protective device that it's like it is quite common for residual current device or earth fault protection. There are mainly three main type of devices. I have copied here, let's say, two important tables. The table defining the maximum break time in case of arc, and depending on the arc current. So for an arc current of 2.5, a series arc current of 2.5 amp, the maximum break time can be 1 second, and for 5 amp is 0.5 seconds, etc., etc. And for the parallel arc, we count the number of half cycles, and depending on the parallel arc current, the number of half cycle are defined here with a maximum number of half cycle to be detected. So all of this is covered by IEC 62606. The standard was published, the first edition of the standard was published in 2013. Then there was two amendments, one in 2017, which is shown here, another one which was published recently in 2019 to update the standard, and the standard is, let's say, quite well known. This is a product standard, and it's possible to certify, and the devices are certified in well-known test houses and third-party test houses. Then, when you have with such a device, it is now possible, coming back to my initial test with a heating fan. So, I stop the sound. So if I insert, okay, I start again. If I insert an AFDD in the circuit with the heating fan, with the same system, and with my my arc, you can see that the AFDD will trip. You may have a small spark, but the AFDD will trip very rapidly. So this is exactly what we wanted to what we want to show. So in fact, this technology enables to detect dangerous electrical arc. I did not go so much in detail in the, let's say, the technology and the standard, but one important aspect is to detect dangerous arc and not to detect non-dangerous arc, which can occur, for example, in a switch, or in a contactor, or in a motor, or in any of the loads which are connected on the electrical circuit. I think I have another. This is another video which was done more recently, showing another fan with the protective device. Maybe I have the pointer. So the protective device. So we have made some tests with several brands of protective device, and showing how the fire can start with this in this case. So here I think we have some fire starting quite rapidly in a damaged cable on this carpet. And if you improve your fire prevention, you see the same test. You can see a small smoke, maybe you can see it, but the device trips. Maybe this is not easy to see here, but you can see that the device, the AFDD trips. In each case, you have a tripping of the device due to the arc. So this is to show you that this technology exists and needs to be to be used and can be used. Okay, so now the question is when can this technology be used, and in which case it should be used, because okay, it's very good to see that it's possible. There are important files. It is possible to detect electrical arc, because electrical arc can create a fire. So there are some product standards. There are some products on the market very well. And now, what about the application of this? So in fact, what has been done at IEC level is a risk analysis matrix, analyzing the criticality of fire as being the product of the severity, the occurrence, and the probability of non-detection. So the severity covers the impact on person, on livestock, on properties, and it can be rated from insignificant to catastrophic, from 1 to 10. The occurrence depends on the type of building, the structure. It can be rated from remote to almost certain, from 1 to 10, and the non-detection depends on vigilance and the density of occupation. So, of course, for example, if there is somebody sleeping in a place or in a room or in a bedroom, and there is a fire, the likelihood to detect is lower than if there is somebody who is taking care of the building. So this is the principle. 33 types of building have been listed, from airport to schools and hotel and factory, etc. And each building has been splitted where relevant in various functional areas, from working areas, communal areas, sleeping areas, and storing areas. So this is this work. So the outcome of this work is this big matrix, 33 types of building, 8 functional area, 264 case. For each of the case, what has been assessed by experts in as I said before, the severity, the occurrence, and the probability of non-detection. And this gave some values of criticality of a fire. Methodology was shared also by some investigation laboratory for fire. And the red cells here show the places where the criticality is the highest. The method has been referred and is published is referred to in the IDC website. And based on that, this has been the basis for updating the installation standard to recommend or to require, in some case, the circuits and the application and the building where protection should be done in order to address the most critical case. So what is the priority circuit that to be protected? First of all, the sleeping areas. So this is also something which has been detected in North America for application of AFCI. So the sleeping areas, especially for children, kindergarten, elderly people, disabled people, but also for hotel, bedroom, etc. The location with combustible material, with flammable material or environmentally conscious hazardous products. The areas where irreplaceable property is stored, museum, historical buildings, etc. You know that in France we have, you may know that in France we have a very well-known Gothic cathedral from the 14th or 15th century, which was built, which burnt 4 years ago due to a fire. So this is something that needs to be protected. And for the area with large group of persons where escape is not so easy, like airport, railways, stations, cinema, and conference rooms. So finally, very happy to say that the installation rules, so at IEC level, the IEC 60364 will require, well, it's not completely done because the standard is at the very, very last stage for voting, but it will require enhanced protection for some application, and the standard is likely to be published in 2024. So this is IEC 60364-442, which is protection against thermal effect, which will require the use of arc fault detection device to protect against fire or against arc fault in final circuit. So this will cover the 5 bullets here. I think that's interesting to have in mind. The standard will be published in 2024. So first location intended for people to sleep, facilities for elderly people, people with disability, hotel, elementary school, kindergarten, etc. Location intended to be occupied by a large group of persons. Location intended for storage of flammable material. Location intended for storing irreplaceable goods like museum, historical building, archive, and agricultural premises where livestock are kept. There are some examples of important fire in agricultural premises, and this also was identified as something, some circuit to be protected. Of course, the standard says that for AC circuit, the use of arc fault detection devices, AFDD, in compliance with IEC 62606, will satisfy the above recommendation. So, and all those circuits, this is also something important to know, will have to be protected by an RCD of 300 milliamp, which is also something which is not really new, which already existed in this chapter 42 of IEC, but which has been increased to the location which have been identified here. So, what is the situation in various countries? I think that's interesting to see that some countries have already implemented some requirements related to arc fault detection devices. So first of all, Germany, in fact, they do, well, it's indirect. They require a kind of risk assessment to be done for fire protection. And depending on the result of this risk assessment, they require to install devices to protect against dangerous arc like ABs. Secondly, in UK, United Kingdom, they require the use for arc fault detection devices for some applications, for some circuits, where the risk of fire is considered to be high. As far as I remember, there are some circuits such as circuits supplying student bedrooms, but there are also some other applications. Austria also requires arc fault detection devices since January 2019, sorry, and India just modified their national electric code and now require arc fault detection devices for some circuits. So these are the there are for sure. I did not mention USA because for USA it's not the IEC word, but USA, Canada are the countries requiring protection against dangerous arc, and this is for sure done. And there are some countries recommending, so it's not a requirement, it's a recommendation, like China, like Netherlands, Norway, Sweden, Poland, which introduced arc fault detection device recommendation. France also is recommending arc fault detection devices for some application. And some other countries like Russia, Korea, today they are considering to enhance their installation standard to better protect against electrical fire. So it's a kind of summary. So because I have made a big focus on arc protection because this is really new and this is really starting and booming everywhere. So how to improve your protection against fire? So this is This is a guide. So of course, depending on the earthing system. So you have the power circuit and the final circuit each time in TT, in TN, and in IT system. So you have the standard protection, which is shown here, and the advanced protection, which is recommended here. So for TT power circuits, circuit breakers and RCD are standard protection, and in final circuit it's the same. But in final circuit, no, it is really something which is new to add arc fault detection devices to protect some final circuits. In TN, earthing system, circuit breakers for sure are classical, and for power circuit and final circuit. And now for final circuit, for sure, so you should use RCD of 300 milliamp, as I said, and to protect all final circuits, to add arc fault detection devices. And in IT system, it's the same, but in IT system, of course, usually we use installation monitoring devices, but in IT system, also for final circuit, arc fault detection devices are required. Then there are some other additional measures, but which are not standard. But the compliance of the switchboard to 61439. There are some devices which are intended to detect a hotspot in switchboard, which can be used as well. But I will not go too much in detail on that. So this kind of summary is a table which I can circulate my presentation, which lists the key points to consider for electrical fire prevention, and it's a kind of checklist. Of course, you have to consider either existing installation or new installation, and in this case, you will see that you need to consider for sure compliance to 61439, because it's also something important. Installation of 300 milliamp RCD, arc fault detection devices, etc., etc. So this is accessible in this link, which is shown just below. So as takeaway. So protection against electrical fire needs to be strengthened. We still need to improve, and you have seen my figures. Electrical fire do not really decrease. There was a decision at IEEE level. This is why it has been decided to revise this chapter 42. There was a decision at IEEE level to improve the level of protection against fire. So this needs to be strengthened. I think it's important to have in mind that 60364 will soon mandate arc fault detection device for some very specific application and location and circuit where criticality of fire is very high. It will also mandate an extended use of 300 milliamp RCD to protect against insulation fault, which is not so well known. It was already the case, but it will be extended in all those cases where criticality of fire is high. Each country should consider to implement 60364 according to its local priority. And I think that's important to have in mind. IEC 60364 is guiding all the countries to implement their installation rules. It's giving the state of the art, and I think it's really good to consider. I have given a link below to specify enhanced protection against electrical fire, and you can consider this is a fire protection guide which has been made by my company, and which is really accessing freely at the link which is given below. And I think that's all. So thank you for listening to me, and I hope this is clear, and if needed, I can answer your question.
you so much, Sir Jean, for that very informative presentation. Are there other questions? Yes. Are there questions on the chat box? Or
I
were
have a
there
question.
questions sent to your personal chat, sir?
Casey.
Sir?
Yes, I have a question to Jen
Ay,
Fran.
yeah, Sir Conrad, you're acknowledged, sir.
Yes, Jen Francois, thank you very much for joining our webinar. And of course, thank you to Paul for inviting you. Nice to see you here around. I have one question with regards to the frequency of the AFDD. You know, in the USA, there are 60 hertz, but the voltage required for the FDD is rated at 120 volts. In the Philippines, we are using 230 volts as our nominal voltage for residential and 60 hertz. Now in Europe, the IEC standards, actually it's for the AFDD product standards. The available, I think, products are more on 230 volts, but 50 hertz, 50 hertz, no? So what could be the, of course, we cannot use, I think, what are the rationale behind this frequency selection application for nominal frequency from 50 or 60 hertz, especially now, you know what happened to our code before, we specified in our code the application of AFCI. Of course, our code is based on the National Electric Code. We specify arc fault circuit interrupter. But after that, there is no product available in the market. So what the PEC committee have done is to remove again this part of the code because it's not actually it's not relevant because product is not there. Now, if for example we use IEC, can we address the product standards? Okay, can address the requirements here in the Philippines for a 230 volts, 60 hertz. That's my question.
Okay, in Philippines it's 230 volts, 60 hertz, if I remember
60 hertz,
correct.
yeah, correct.
So in fact, so first of all, the standard covers both case 50 and 60 hertz, 230 volt, 120 volts. So in fact, the IEC 62606 covers all those cases. Okay.
Okay.
So it's a first point to have in mind. However, it's clear that the products which are today on the market are rather either 230 volts 50 hertz or AFCI-like devices 120 volts 60 hertz.
60 hertz, yeah,
and I don't think, at least my company does not provide 230 volts 60 hertz for the time being. It's possible. It's really possible. There is no impossibility. It's not a technical challenge, but it has to be tested, validated, and certified. So this is more a question of certification, but there is no. It's really something which is possible, which is really manageable. But it has to be. The tests are quite long to verify that you detect all the cases which are required by the standard, and that you do not, let's say, create a nuisance tripping or unwanted tripping for some specific case. So all those tests have to be done. There are some EMC tests, etc., etc. So it's quite long. It's quite long test, and as far as I know, but I can answer to you more in detail. There are no, at least from my company, there are no devices at 60 hertz today.
So
for the time
what
being.
do you think?
But there are other countries requiring
Yeah.
60 hertz. I think Korea also is requiring 60 hertz.
Yes. So I think this is more on the demand side. No manufacturer because actually our installation here is unique. You know, okay, it's USA AFCI 120 volts, 60 hertz, and here in the Europe, of course, major manufacturers like your company is 230 volts, 50 hertz. So if we discuss now about, I think for the meantime now, since the product is not available, but there is another company, I will not mention, that they have already developed this 230 volts, 60 hertz. Since you have said that the standards address both 50 and 60, so we don't have any issue on the standard. But actually, it's more on the demand side of those who will actually use. No, it's also also on the requirement, the mandate. No, if you will be mandated to use all this one, then of course we have to find a manufacturer who can produce it for us. Of course, your company can produce, but it depends. I think more now in the demand of the device. Then maybe it will be very expensive for us if you develop just for a quantity.
Yeah, but I think there are some cases, there are several countries in the world. It's not the first time we have this question asking for 60 years devices. I think there are other countries. I think Brazil also, it's in South America, are using 60 years as well. So yes, very valid point. I think it's not the first time I have this question, so very valid point. I will report this. Yes, I have to report this question. Yes, thank you.
Okay, thank you, Gianfranco. Thank you very much. But I think with DC we don't have any problem. It can be addressed because DC is another aspect of AFCR.
Yeah, it's another aspect.
On the DC
it's
side.
Another aspect.
Okay,
yes, it's another aspect. And it has
Okay,
been presented
Casey?
just before. Very interesting.
Thank you, Casey. Take it away. Thank you, Casey.
Thank you, Jean. Thank you, Sir Conrad. Some other questions in the chat box, sir. What is the difference of the open circuit fault what is the difference in series and parallel arc fault?
Difference between series and the parallel arc fault. Yeah. So in fact, maybe I can show again to my presentation because it was said here. Are you still seeing my screen? Or maybe
Not
I have
yet,
to
sir.
share again. I have
You
to
can
share again.
reshare po.
I will share again, sorry. Yeah. If you see my screen, yeah. You should see my screen now.
Yes, sir, but it's not on presenters mode.
Yeah, okay, I will come. I'm just seeking for the difference between. Yes, or maybe I have something at the end which is more clear. Wait 1 second. Normally I'm looking for. I don't have it here. Okay, so I will just use what I have here in order not to spend too much time. Okay, well, it's not very. So this is the video I shown. I would miss a kind of schematic, but in fact, the series arc fault was on the left hand side. It's an arc which occurs in series with the load. In fact, so the load, the current is flowing in the conductors and going to the load. And the series arc fault is typically it can be an arc inside a connection, and the arc will be in series with the load. Therefore, the maximum current of the arc is the maximum current of the load. And it's not easy to detect because it's not a short circuit, it's not an earth fault current, it's just a current which is a fault which is in series with the load. This is the series arc fault. The parallel arc fault is what is shown here on the right hand side. It's sometimes we can call it impedant short circuit. It looks like a short circuit, but it's not really a 0-ohm short circuit. It's a carbonized path between two conductors, which create a current between two lines, but without being a short circuit. So these are the two cases: series arc fault in series with the load, parallel arc fault, which is you don't require the load for the parallel arc fault. You just require the voltage between the two lines and the carbonized path. Did I answer your question?
Yes, sir. Thank you so much. Our participant can get back to the recording if he missed something. Thank you so much for answering, sir, the questions.
For sure. You're welcome.
Are there any other questions from the panelists?
There is
Sir Brian,
Casey.
you raised your hand, sir.
Casey,
Yes, sir.
there is one message here addressed to me. Just want to clarify this.
Sure, sir. Go ahead
Yes,
po.
to Lenor Barbosa,
Mhm.
because I think he did not hear properly what I mentioned about the deletion of the AFCI in the PEC 1 2017 edition, because the product for 230 volt 60 hertz is not locally available. So it's not GFCI, ground fault circuit interrupter. We are not talking about this. We're talking about the AFCI. And similarly to the AFDD of the under IEC standards, not also available in our application. Okay, I think that I hope that to clarify this. Okay, thank you.
Okay, sir. I think Sir Brian, sir, is raising his hand. Sir Brian, you're acknowledged, sir. You may also open your video, sir.
Yeah, thank you, Casey.
Thank you, sir.
Yes, Sir Jean. Regarding the two types of arc faults, the series and the parallel. So, which one do you think is the more problematic in terms of detection? Is it going to be the series arc fault or the parallel arc fault?
In terms of inspection, you mean?
Detection.
Detection.
Yeah.
For me, the most technically, from technology standpoint, most difficult to detect is a series arc fault, because you have to detect a phenomena which is detected by measuring the load current, and the load current is, as I said, is flowing in the load. And at the same time, it's not exactly the normal load current, because there are some arc, as I said, there are some high frequency noise, there are the wave shape of the current is not the same, the wave shape of the voltage is not the same. So let's say the most difficult technological part is the series arc fault to detect.
Can ordinary circuit breakers detect the parallel arc faults? Sometimes, yeah.
This is a good question. Yeah, we had a lot of discussion about that. In fact, the parallel arc fault can be quite low. It's a quite of impedance short circuit, and it can go below the magnetic tripping current of a circuit breaker. So this really depends on the type of circuit, the type of circuit breaker, etc. But it can be, it has been proven to be below the magnetic current of the circuit breaker.
It depends on the arc impedance of the
the
path,
yes,
the path, right?
Exactly. And it's very impressive to see how an arc can create a fire. It's really very impressive. I have shown a few videos, but it's very impressive how to see an arc, how an arc can create a fire.
So really the arc fault circuit interrupter in certain areas should be mandated, no? because of
Yeah,
this.
this is what I'm saying. This is what I'm saying. In fact, this has been mandated in USA, as you know, in the National Electric Code in USA and Canada, and also in some cases in Mexico. This is in the process to be mandatory at IEC level in IEC 60364, which is the installation rule for some application. As I said, the standard probably will be at the final voting stage in May this year, in May, yes. And it's very likely that it will be voted positive because it was really supported by most countries. And when voted, then depending on the application of the country, but depending on the application of the country, it will become mandatory if the country adopts the IEC.
Thank you, Sergio.
You're welcome. You're welcome.
Okay. Okay, any other questions, sir? Any other questions from our panelists also? All right. For the other questions, you may be thinking later, so you can reach our presenter via email, or any unanswered question will be forwarded to our author. And please expect his response via email within 48 hours. Okay. Let us now proceed with the awarding of the Certificate of Appreciation. Once again, in behalf of the IIEE Standards Committee, thank you so much, Sir Jean, for your time and for your effort in sharing us your topic. So we read the citation of the certificate. So the Institute of Integrated Electrical Engineers of the Philippines presents the Certificate of Appreciation to Engineer Jean-Francois Ray for imparting valuable insights as technical resource speaker on the topic Protection Against Thermal Effects in Electrical Installations, Recent Breakthrough in Technology and Standardization, during the technical webinar entitled Standardization Challenges in Electrical Fire Prevention, held on March 6, 2024 through Zoom conferencing. Signed by Engineer Conrado C. Binondo, Chairman of IIEE Standards Committee, Engineer Joseph Darren Claire S. Solicar, National Secretary, Engineer Esperanza A. Collado, the National Vice President for External Affairs, and Dr. Florigo C. Barona, National President. Thank you so much, Sir Conrad.
Thank you very much. It was a pleasure to be with you today. Thanks a lot.
Thank you, sir.
Casey?
Yes, sir. Go ahead, sir.
Yes, of course, we cannot close this webinar without thanking one of the friends here in the IEC. I would like to acknowledge the presence here of the IEC TC64 Working Group 43 Convener, Mr. Paul, please. He's in our room now. Paul, thank you very much for inviting Jean-Francois for this event. You can see Paul. He's based in Singapore. Hello, Paul. Can you say something? You're mute, Paul. You're mute. Yeah.
Yep. Now I'm on. And I think on behalf of IEC and also from my company Schneider Electric, it has always been our pleasure to impart whatever we know and to share and to exchange some of the technical knowledge that within the electrical field and beyond. Particularly now, very interesting. As you know, we are moving towards prosumer, PV, EV. So the boundaries are very close. It's starting to move beyond the traditional electrical installation. So it is a very interesting time, and then that's where practitioners like yourself play a very important role in ensuring safety as electrification, new technology starts to cross over the border from the grid into the home. So it whereby safety is the most important, whether it's fire or electrocution. And thank you for giving us the stage to share the knowledge.
Thank you,
Thank
Paul.
you so-
Thank you. Okay, Casey, go ahead.
Thank you so much, sir. So before we part ways, sir, may we ask our National Treasurer, Engineer Lopez Justo, Sir June Lopez, our National Treasurer, also a professional electrical engineer, a CEN Chartered Professional Engineer, and also IEE Fellow Grade and the IIEE Most Outstanding Electrical Engineer for Construction and Project Management for 2010. He is also a Philippine delegate to the IEC conference in Sydney, Australia in 2018 and a Philippine delegate to the November 2022 IEC WG43 conference in Tagaytay. And also last January 24, the Philippine representative to the IEC WG conference in Singapore. He is one of the distinguished leaders in IIEE and also one of our advisors in the IIEE Standards Committee. Without further ado, may we acknowledge Engineer June Lopez, our National Treasurer, for the closing remarks. Sir June.
Can you hear me?
Yes, Sir June.
Yes, loud and clear.
Okay. Good afternoon to everyone. I'd like to thank Chairman Conrad of the Standards Committee, Engineer Chris Vic Magdali, and Engineer Jean-Francois Ray for sharing to us their valuable presentations. I'd like also to greet all the participants and the panelists. We hope you have gained insights and understanding of the topics presented and discussed by the speakers. It's the fire month, and it's just but right to discuss these things. In our present modernized electrical systems, standards are not only important, but very crucial. Good and accepted standards equate to safety. This prevents fires, accidents, injuries, and worst of all, fatalities. It is therefore essential to prioritize the use of accepted standards, be it American, be it European, or whatever, to prevent all of these things mentioned. As electrical practitioners, I therefore encourage all of you to keep abreast, learn the standards, and be updated, since standards evolve and change. What may be applicable today may not be after a while. I shall leave you with this statement. Use the proper accepted standards. Use the proper accepted standards. Execute the installation per code requirements and best practices. Thus, if these two are met, we attain a safe and reliable system. I'll part this with this message. To err is human, but we err less when we use accepted standards in our profession. With that, I say good afternoon, sirs. Thank you very much.
Thank you so much, Sir June, for that very warm closing remarks. We are really very encouraged and inspired with your message. Before we part ways, may we ask all our panelists and participants to open their camera for the photo op.
Open your cameras. for the
You
photo.
open your camera, sirs.
Yes.
All right. Take it away, Micah. 1, 2, 3. All right. We capture everything. Second page. Okay.
Dami pa.
We are around more
1,000.
than 1,000 participants today. So
Wow.
we'll be having more pages for the pictures, sir. Thank you so much to everyone who participated in our webinar and to our panelists, guests, and speakers. Thank you for your support to IIEE. Good afternoon.
Good afternoon.
Thank
Hi,
you.
Paul.
Good afternoon, everyone. Thank you.
Good
See you,
afternoon.
Paul.
Bye-bye. Thank
See you
you.
all.
Thank you.
Jen,
Bye-bye.
François, thank you very much.
Yes.
Thank you. Bye-bye. See you.
Thank you
See
so
you.
much.
Bye-bye.
Casey, bye-bye.
Thank you, Casey.
Thank
Nice
you, sir.
MC. Thank you.
Thank you, Casey. Chairman, congratulations, Chairman.
Yes. Thank you very much, Mentor Jun, for the support. Of course, our IIEE Tech, Ma'am Maika, thank you very much also for your support, and Sir Warren, thank you. And all those
Micah,
behind the
thank you,
technical team.
Micah. Yes.
Micah, thank you.
I'm not in Qatar, I'm here.
Chat with you, Sir June.
Yeah. Okay, bye-bye.
Okay,
Bye,
bye-bye
sir.
now. Bye-bye, everyone.
Bye, sir.
Take care, take care.
Bye,
Thank
everyone. Thank you.
Casey, usap tayo dun sa
Yes,
pinag-usapan.
sir.
Okay,
Yes.
thank you. Bye-bye.
Bye, sir.
Bye.